Welcome to Mastering Mean Web Development. I am Luke Madera, and I've spent over 3 years working with full-stack JavaScript using Mongo, Angular, and Node. And in this video course, we'll be teaching you to build a site using the mean stack. There are many mean stacks. We're going to use Meanseed for this course. And mean stands for Mongo, Express, Angular, and Node, which are the main technologies we'll be using. They're all based on JavaScript, so there's only one main language for scripting to learn. And we're going to start with a seed that gives us something like this, where we can chat using sockets, just a basic kind of scaffold out website, and then we're going to be able to build something that is a fully featured responsive website, such as this. So that's an overview of this course. In terms of the particular technologies, so Yeoman is a generator that is comprised of 3 technologies: Yo, Grunt, and Bower. Bower is a front-end dependency manager that is akin to the back-end dependency manager for Node, that is NPM, which stands for Node Package Manager. Express is a lightweight framework that we use on top of Node. MongoDB is our database. Jasmine, Karma, and Protractor are our automated testing tools. And Angular is kind of our big powerhouse in the front that is our front-end JavaScript MVC framework. So that's a really high-level overview of what we're going to be doing in this course. In the next video, we're going to actually go ahead and set up our mean stack. In the last video, we gave an overview of the course, and in this video, we're going to actually go ahead and set up our mean stack. So the first thing we're going to do is go to GitHub, which is a popular source repository online. And we're going to search for mean, and we're actually going to search for Meanseed in here. Again, there are a lot of different kinds of mean stacks. We're going to sort here by the most stars, and we're going to go ahead down to this generator Meanseed right here. And if we click on this one and scroll down, we can see that it will give us instructions to get started. So the first thing to do, if we go to the Getting Started section, is to install these global NPM, which again stands for Node Package Manager, dependencies. But before we do that, we have to actually make sure we have Node installed. So you can follow the individual instructions depending on your operating system, whether you're Mac, Windows, or Linux, to actually get those programs installed. So we can just click on here if we're running Windows, for example, and it will actually give you detailed steps to go through: getting a text editor, installing Git, installing Node, installing MongoDB, which is our database, Phantom.js, and then making sure we have Java installed. And then once you have all that done, you can go ahead and go back to this main page here, and we can install our global Node dependencies. So you can just copy that and then go to a whatever console you have. So in Mac, it'll just be terminal, and in Windows, you can just use the git bash. And so if we go to a new directory, and CD just stands for change directory, and 2 dots means going back, we can just install these, what we copied, and we can let that run by pressing enter. So this will take a while to run. Just let it run to completion. And then once that's done and completed, we can go back to the instructions and go to the next step, which tells us to install the generator. So we can copy that line and we can paste that and press enter. And again, let that run and complete. And then once you've done that, again, go back to the instructions for the next step, and we can run Yo Meanseed, which will actually trigger seeding our mean stack. Now, there's a note down here about Yo Configs, which is going to tell us the title of our app and some other just configuration. So we're going to go ahead and follow that step. So it talks about this Yo Configs folder, which we can click on for an example. And if we go here, we can see there's this default.json file. So we're just going to copy that. We're going to make a folder, and we're going to put a default.json file and then edit it in a text editor. So we can click on that to see an example, and it just has some prompts and some different options here. So we're going to make a new folder, and in that folder, I'm just going to put it here in websites. We're going to say new folder, and you can do this from the command line as well. And we'll say Meanseed, and inside of this folder, we'll make another new folder, and we're going to call that yo-configs. And then inside of that, we're going to make a new text file, and that is going to be our default.json. So we'll just do text document, and we're going to call it default.json. And then we can open that up in a text editor. I'm going to open it with Sublime. And then in here, we're going to paste that copied code from the default.json example. So we can paste that in here. And then you're just going to go through and change it to what you want yours to be. So this is your new project, and we're going to call it Mean Company, let's say. We can say Mean Company here, and then for the title, Mean Company here. You can change that to description. And if you have a GitHub handle, you can put that there. Put your name in here. I'm on Windows, so I'm going to change this to Windows. And everything else you can pretty much leave the same. So once you have changed those, you can save that file. And then when we go back to our editor or our console, we can go into that directory. So again, cd is for change directory. And we named our folder mean seed. And if you press ls to list out, you can see we have this yo-configs folder. And that's what mean seed will run off of. So if we type yo mean seed, and we're going to pick the first one, core default, and it will ask us what config file to use, and by default it's going to use yo-configs default.json, which is the file that we just created. So we can just press yes, and then it's going to run a bunch of stuff to actually seed out our application. And you can just let this run until it finishes, and then we will circle back in the next video and actually view our now scaffolded out site. In the last video, we installed our mean stack using the yo mean seed command. In this video, we're going to view our new website. So the first thing we can do is open a new tab in the console and go to our mean directory that we created and type node run.js. Now before we do that, which is going to run our server, we can open a new tab and make sure our Mongo server is running. Now depending on how you installed it, it may already be running, but if it's not, we can type mongod from any directory and it will start our Mongo server or our database. And now that our database is running, we can start our server. So now we can see that our server is running and listening at HTTP localhost 3000. So we can open a browser like Google Chrome and we can go to that URL. And here we can see our site just as it's originally scaffolded. So that's how we view our site after running our node server. And in the next video, we're going to go through the web debugger to view our code in our browser. In the last video, we ran our node server and then opened a browser to see our site. And in this video, we're going to look at the web debugger. We can right-click on the page with Google Chrome and click on Inspect Element. And you'll see it bring up this console at the bottom here, and there are a bunch of tabs at the top. The console will show us if there's any errors on the page and any high-level information, or when we use logging, like console.log, it'll show up here. And the Elements tab will show us our HTML, and we can hover over it in this debugger down here, and then we can see up on the page it highlights a different color. You can also right-click on a particular element and click on Inspect Element, and it will take you to that particular element that you clicked on. So if we right-click on Test up here, we can see it took us to a different place and it shows us our HTML. So we can actually see our HTML in the debugger. And you can actually type into it and change it. So if we put 1.1 here, we can see that it updated in our browser. Now if we refresh the page, it'll go away because we're just editing it live, but it's nifty if you want to test out some HTML or CSS changes without having to go back and forth. And if we click on the Sources tab here, that's where all of our JavaScript is. And so if we look in here, we'll go through the folder structure later so you'll know where to look, but in SRC modules, We have directives, pages, and services for Angular, and you can look at any of them. In this case, we're on the test page in dev test. So if we go to that file here, we have testcontroller.js. This is our JavaScript file that is being run on this page. And if you click on a particular line, you can make a breakpoint. So if you then refresh the page, we'll see that we're paused in the debugger, and we can actually step through and debug our code. So a lot of really cool tools that are just built in to browsers, especially Google Chrome, that we can use to debug and inspect our code. So for the next video, we will look at Grunt, which is a build tool for creating all of our files for our app. In the last video, we looked at the web debugger, and in this video, we're going to go over Grunt, which is a build tool for our app. So grunt Q is the most common command that you will run. Q just stands for quick, and this is going to just build our files for it. It tells us our output right here, so it does linting or hinting to make sure we don't have any syntax errors. Uglify is something that minifies our code so it's smaller and more performant, and we build some CSS files in our final JavaScript file, and it shows you the directories if you want to look at those. And you'll need to run GruntQ anytime you change an HTML file or a CSS file. And there are other grunt commands we can run as well. Grunt by default is the main one, and that will start out the same as the GruntQ task, but it will actually run tests for us, and both on the back end and the front end, as well as end-to-end tests. And that's really important to have automated testing for your site, and we'll go over that more in a later video. But we can see here it's running a bunch of automated tests, and they all passed. And now it's going to run some Karma unit tests, which are front-end Angular tests. Again, we'll go over more later. So this is the full grunt task, and we'll quit it right now with Control-C, but you can let it finish, and it'll run end-to-end tests as well. There are other grunt commands as well, and you can always look them up in the documentation, which is in grunt file. Grunt file is in our main folder. So if we go to mean company, our main folder, we have this gruntfile.js, and if we open that in our text editor, we see here at the top we have documentation for all of these different commands that are options to us. So you can go through and test them out and read the documentation, but we're just going to go over grunt dev for now, because if you remember, I said a minute ago that you have to run GruntQ every time you change an HTML and a CSS file, and that can get pretty annoying if you want to keep on making changes to keep on having to come back and run GruntQ. So grunt dev is a watch task, which means it will, every time you save a file, it will actually track those changes and then automatically do things for you. In this case, running GruntQ for you automatically. So to use that, we need to install something called Live Reload. So if we just Google Live Reload, for Google it should come as an extension, a browser extension, and so we can see here the Chrome Web Store. We have it here. And it's a free extension, so we can just click here and add it to our Chrome browser. And then if we click on it, we can enable it. And now if we go back to our site and we run that grunt dev task, so you just type grunt dev as the documentation says, it will start out by running GruntQ, but then it will end with a waiting line that tells us it's waiting for code changes to happen. So we can see right here it says waiting. So if we open up a file, we'll just change our test file. So we'll go back to the modules, pages, dev test file that we're actually viewing. And we'll open this HTML file that normally we would have to rerun GruntQ if we change. But now if we save it and we look back at Grunt, we see that it noticed that it changed and it automatically runs Grunt for us. And if we look at our browser, we can see that our browser automatically refreshed for us. So instead of having to press refresh and to run GruntQ on your own, the grunt dev task will do that for you. So that's a quick overview of Grunt, which is our build tool. And again, you can look through the documentation for the other commands. And in the next video, we'll be going over configs, which sets the configuration for our application. In the last video, we went over Grunt, which is our build tool. And in this video, we're going to go over the configs, which configure our application. So we can find the configs in the main folder and then app configs. And we see we have two files. You'll notice that the config files always come in pairs. and we will open the regular one. The test one will be used for automated tests, which we won't bother with right now. If we open this file in a text editor, it's just a JavaScript object or JSON file, and it has all of these properties. And if we look at our application in a browser, we can see at the top it says Mean Company here as the title in this tab. If we wanted to change that, that's actually set right here as app title. And so if we put another thing that says edit here and we save that and then we rerun grunt queue, once that is updated, if we then refresh our site, we can see it says edit up here. So that's basically what the configuration file does. It does a lot of other things other than just text. It has connection strings for the database and for the Node backend, as well as third-party services, so Facebook and Google credentials. And in general, it's a way to abstract away information. So if you have different environments, say you have a development server that has, a different Google client ID or a different Facebook app associated with it, or you want to name it something different for production versus development, you can abstract away all of those hard-coded values and put them in a file here and then reference them in your code. And it's especially important for credentials. You don't want to hard-code your credentials into any of your code anyway because it's not secure. So that's a quick overview of the config file. Now I mentioned these other versions of it, so they always come in pairs. And if we want to make another pair, we can copy them and we can rename it with a hyphen after the config. And a common instance may be if you have a Mac, you're going to need to set the platform to Mac. So if we do config-Mac and then we open that, we can change our operating system from Windows to Mac. And that will handle some path things to make sure that it works on a Mac machine. So you'll have to do that if you have a Mac. And if you save that, we'll have now an updated config file, but we don't know to use it. So first thing we need to do is we need to make our test pair. You always have to have pairs. So to do that, we just copy our new config and we just say .test at the end here. And now that we have our pair, there is this file that's called config environment, that is in the app folder right here. And if we copy this file and we put it in the main folder, we can then edit that file and we can make the line here say Mac, which is just the thing that is after the hyphen in the config. So if we leave it blank, it'll just go to the default config, which is config.json. And if we put in Mac, it'll go to the config Mac.json. And you can make as many config pairs as you want. If this was called Mac1, then you would put Mac1 here, and it would go to that set of configs. And so in that way, you can have, again, different configurations for different environments or different people or systems, but the same code base. It just will run a different set of configs. And if we want to look at the config file again, we can add properties. So if we wanted to say add New Relic as a service, which is performance monitoring, we can just make a new property and we can say, we have an API key and whatever the name of your key is, you would put there. And then you can reference it in your app with config.newrelic.api key. And so again, that configs are a good way to abstract away all of your kind of hard-coded stuff into one place and have different pairs. And if you ever want documentation on the configuration files, they're all documented just like most of the stuff in the docs folder. So if you go to docs, and then in this case it's in files, configs.md, we open that file up and it will go over everything we just talked about, how to create a new config pair and how to use our config environment file. It goes through right here. So that is how to use configs. And in the next video, we'll go over taking our code that we have locally for our app and putting it onto GitHub so we can actually set up those different servers and other developers can work on our code. In the last video, we went over configs. In this video, we're going to use GitHub to sync our local code onto a server that then we can access from a different computer for, say, a different developer, or that we can access on a production or a staging site so we can move our code around between different machines and environments. So just go to a browser and go to github.com. If you haven't already signed up for GitHub, you can sign up, and once you are all signed up and you can connect to GitHub, which You can just Google and figure out how to do it, but there are also our READMEs in the docs folder. So if you go to docs, setup running, and then setup detailed, it will tell you, git config global username to set your name and then set your email. You can connect HTTPS or SSH, so you can set keys for that. And again, you can Google that. It's pretty straightforward. And then once we can connect to GitHub from our computer, we can go ahead and create a new repository on github.com. So just new repository over here. I'll just call it mean1 right now. We can put a description. Make sure the README is blank. We're not going to initialize anything because we're going to use the code we already had that we used the mean seed generator to create for us. Just click create repository, and now we have this new repository and it gives us a location. Again, there's HTTPS or SSH, and it has these instructions for us of how we add a remote, which is the way we tell a particular environment which different servers it can basically access code from. So it has it all here. You just copy this and paste it in, and that will add a remote. I've already done so. So if I just go to get remote V, I can see that I already have an origin set up here. Origin is the default name that people call it. You can call it whatever you want. You can have multiple remotes in the same repository, but the default is just have an origin. And so once we have done that, we can push it. And so when you push it, then the code will basically show up in GitHub for you, and then you can access it from any other computer. So the one that I already have set up is the mean company. So if we go here, we can see this is what it looks like once you've already pushed it. And then you can do git pull origin master. And again, origin is just the name of the default repository remote, and then master is the default branch, which it says right here is the master branch. So we can try and pull to see if there's any code updates. There aren't any, so it says up to date. We can then push to master if we have any, which again, we don't have anything to push right now, so that won't do anything. But once you have it set up on GitHub, then you can pull and push, and you should be all set to go. And in the next section, we'll go over all of the mean technologies. In the last section, we went over setting up our mean seed stack so we could start coding. And in this video, we're going to go over JavaScript, HTML, and CSS, which are our front-end languages. So if we look at our files, we can see that there is an app folder, and inside of that is an SRC, which stands for source folder, where our front-end files are. And inside of modules, we have directives, pages, and services. We're just going to take a look at our dev test page. So if we go into the test directory, we can see we have an HTML file and then 2 JavaScript files. The .spec one is a test file. We'll come back to that later, but for now we're going to focus on the HTML and the JavaScript file. And you'll notice there is no less file here. Not all pages require one, but we can create one. So we will take our HTML file and we will just paste one in here, and we will rename it test.less. And then we will open that up in a text editor and blank that out, and we can start adding to this a little bit later. One thing we'll need to do is include this new file we created, and the way we do that is in build files, which we will go over a little bit more later, but in config there is this build files modules.json, and this basically tells us all of our files that we have. So if we search for test.html, we see we have the 3 files we just looked at in that folder there, and we just need to make a new entry for our less file that we just created. So we'll just call it less, because that's the type of file it is, and our file we called test.less. And if we save that and then rerun grunt, we will now have this file be included when we run our page. So first thing we'll do is we'll just look at our page by default. So if our node server is running, we just see it says test and it has this ID false here. And we're going to take a look at the HTML and see why it looks like that. So if we go back to our test folder, open test.html, we can see that we have this div here, and then test br is a tag that is for a line break, and then we have user output right here. So HTML is basically just the layout, and it has divs, which is mostly what you're going to see, and you can just think of a div as a box on the page. So if we look back at our page, this div is a box right here, and then this div is another box right here. These are our line breaks right there. And that's really all HTML. It's just a bunch of boxes on a page. And if we want to change our HTML, it's just like editing a text file. We save it, and then we rerun grunt. And then we look back at our page. If we refresh, we can see it now says test1. So that's the very basic level of HTML. And without any styling, it's just going to all look the same. But let's say we want to make this change color. And the way we could do that is on our less file, we can say .test. And then we can say color blue. And if we save that and we rerun grunt, that will change our text color. And the reason I put .test right here, this is referencing a class because it has a dot in front of it. And if we look at our HTML, we have class equals test right here. So it'll basically make everything inside this div will be applied these styles, which in this case is colored blue. So if we refresh our browser, we can see now our text changed to color blue. And the final thing we'll talk about is our JavaScript file. So our HTML and our less or our CSS are the things that do our layout and our styling, and if we want dynamic content, that's where JavaScript comes in. So in Angular, scope means a variable that it has two-way data binding, which means if we change something in the JavaScript, it'll show up in our HTML. So if we say scope.myvar for a new variable, and then just say var1, and we save that, and then we reference this myvar in our HTML right here, just say myvar. You basically type everything after the scope dot. So if we look in our control, we have scope.myvar, so we just reference that part. And if we save that and rerun grunt as normal, if we refresh the page, we can now see we have this var1 show up right here. And the cool thing about this is this content isn't hard-coded. So whereas we actually had to change the HTML here for this to change, if we change myvar in the JavaScript, we can have it show up in the HTML. So now if we refresh, we have var2. And here it's really simple and it doesn't show the power over it, but if we were to load something from a database, let's say, this could be one user, and we could load a different user, and the same HTML will now display different users because we can use variables. So that's the big power of JavaScript. It gives you the access for dynamic content. That's a really brief overview of HTML, JavaScript, and CSS, or less. You can type any CSS inside of a less file. Less is just a preprocessor. You can use it just the same as CSS. And again, this isn't meant to be a comprehensive overview of how to use these three languages. There are lots of good tutorials online for those. In the next video, we'll talk about JavaScript asynchronous flow with promises and callbacks. In the last video, we went over HTML, JavaScript, and CSS. In this video, we're going to go over JavaScript asynchronous control flow. So we're going to open up a JavaScript file, our testcontrol.js, and we're going to go over the three different main ways to do asynchronous control flow. The reason you would need asynchronous control flow in the first place is if there is something that happens but it doesn't immediately return, you don't know when it's going to return, and so you need to kind of handle that timing when it's asynchronous as opposed to synchronous. So as an example, a regular function, say function sync, say it takes var1 as a parameter and it just returns var1 right back. If we then call sync and we pass in 5, then we will also console log in here that it's doing it. Console.log sync. And then outside of this, we can say a variable sync return equals calling the function, and then we can console log in the next line sync return. And then if we save that and we refresh our browser and we open our console, we can see that we called sync and then we have 5, and those happened immediately. And we could use our return variable as soon as we called the function. So it's this line 20 executed and then line 21 executed right after it. The timing all went in order. So that's synchronous. Now asynchronous means that isn't the case. So we're going to comment out these guys, and then we are going to make an asynchronous function that is not going to do the same thing. And we're going to simulate the timing with a timeout. So we're going to say function async func, and we're going to say var1, and then we're going to have this second parameter that's called callback that's actually going to be a function. And we're going to make that timeout in here to show the timing difference. And we're going to make it wait for 1000 milliseconds, which is the same as a second. And inside of here we're going to say console.log timeout finished. And then outside of this we're going to say console.log timeout started. And then we're going to, inside of the timeout, we're going to call this callback function that we passed in, and then we're going to call this async func, pass in 5 again, and then we'll pass in a function that we'll just define on the fly, and we will console log in here async done. And the thing that we're going to notice here is the order isn't going to be right one after another. We're actually going to start the timeout, then finish the timeout, then do async done, but they're not going to happen right in a row. We can see it started, it finished, and then it was done, but the started and the finished didn't happen one after the other. And if we were to put a console log here, next line, and save that, and then refresh, we can see that the next line actually runs before the asynchronous is done. So that's the whole idea behind async. We don't know the order that it's going to go in anymore because the function itself takes some time. It doesn't return immediately. So that's the first way to do an asynchronous control flow, is to use a callback. You basically pass in a function which you can define on the fly, or you can set it somewhere else, and then you call that function whenever you're done. And then that function, when it's called, will basically let you continue with your code. The second way to do it is with promises, and promises use the Q variable, which Angular wraps for us, and that's kind of the most popular version of asynchronous with Q. So $Q we'll dependency inject in, and we'll do it here as well. And now we can make another function, kind of like how we had before, that's going to be async func promise, and that's a function. And we're going to pass in var1. We don't need to pass in our callback anymore because we're going to use a promise. So the way we do that is we say var deferred equals q.defer, and then we're going to return deferred.promise. And then we're going to resolve the promise. And whenever we resolve it, that's essentially like the same thing as calling the callback. That's when it will be done. We won't pass anything back. And again, we're going to use the timeout. So copy what we have up here, but instead of the callback, we're going to make that be the deferred.resolve. And then we will change these to be promise, so we know that it's different. And then we will call our function, same as we did above, promise. And then we'll say promise here. And then the other ones we will comment out. And now if we save this and we run it, promise timeout started, finished, same kind of a deal. So it starts and then later on it finishes. Same exact thing that happened. Instead of passing in callback, we just called deferred.resolve, and then if we want to use that, this actually didn't get called because we didn't pass it in. Correct syntax here is going to be .then, which is how a promise comes back, and that will pass back a function with whatever we returned in this resolve, which in this case is nothing. And now in here, we can now console log promise done. Now if we save that and refresh, timeout started, timeout finished, promise done. So same thing as a callback, the same idea, which is just instead of passing a function to call, we actually just resolve the promise using this queue.defer, which you can Google about and read more about, and then you have this .then that gets the function inside of it. So same kind of idea. The third way we can do it, if we comment this out, is using events. So that's generally called pub/sub for publish and subscribe. So in Angular we have scope.on and then scope.broadcast. So on is a listener. So if we say scope.on my event, and then again you can look this up and see the documentation of the arguments, but basically you listen for an event, it gets the event itself and then any parameters that you pass in. And then it's a function, and then inside of here we can say console.log on my event, and then we can just call that scope.broadcast, and then the same thing, my event, the same name, and then anything we want to pass in. And we can use timeouts as well to call it later on in a second. And then just do the same thing. And now if we refresh, we can see on event and on event. So events are probably the most simple because there's no callbacks or promises. You just listen for an event and then you call it whenever you want. And that's a little bit easier. It can get a little more complicated. Promises are generally how things are done most of the time. But sometimes events can be nice. So it depends on your use case, but those are kind of the three different ways to do asynchronous JavaScript. And in the next video, we will go over Angular JavaScript in more detail. In the last video, we went over JavaScript asynchronous control flow. In this video, we're going to go over Angular specifically. So the first thing is that Angular is a single page application. And what that means is that all of the pages load from one single page. So in the src folder, which is our front-end folder, we'll see this index.html file, and we'll have this grunt versions. The grunt versions are basically template versions that will generate the HTML version. So if we look at index.grunt.html, we can see that there are these templating variables right here, this caret and this %sign. And here we're loading in our grunt config, our JSON file, and then we are printing out our title from that. And if we look at our corresponding index.html file, we'll see that mean company got printed there. So index.grunt and index.html are similar files. The grunt file templates the index file. So we'll just go ahead and look at our final file, our index file, and we have our doc-type HTML. Because it's a single page app, this will be the only file that has this. The rest of the files are just going to have the partial parts that are for that specific page. And those partial parts will get put into this ngView directive. That's how Angular works. So everything here, we have a header up here that will be the same on every page. We have a footer in here that'll be the same, and then this is where our content gets stuffed, and this will change on the individual pages. And so if we look at our actual browser, our application, again, we have the header here, and the content we just stuff in here in this content section right here. So that's what makes it a single page application. The rest of the things in this file are kind of generic things. We have some meta tags up here that affect zooming and different devices. We have our title that we already went over. We're including our style sheets right here, which is this is our concatenated compiled style sheet with all of our CSS in it that gets built from our less files. And we have our head and our body tags. We have some code here to handle outdated Internet Explorer browsers. And we already went over this main section. And then we have a whole bunch of JavaScript files that were included for us from build files modules that reference all of our pages. And in the production version, there will just be one combined JavaScript file, but for debugging, it's useful to just include them all. and then we close our body and our HTML tag. So that's index.html. That's our single page that loads all of the rest of our subviews for our app. And the routing for that happens in the common folder in JS and then app.js. And this is the Angular router. We can add some modules. And so if you install something from Bower or another third-party module, you can include it here in the Angular module section. And then we have our configuration, and we decide if we're going to use HTML5 history or not, handle some different devices and works with that. And then we basically just have a whole bunch of root provider win with different routes and what page we show. So as this first line shows, if they type in home to the URL browser bar, it's going to take us to dev-test/test. So we can test that out. Up here we can just type home, and we can see that indeed it redirects us to dev-test/test. If we type login in, it's going to serve the login page. So again, if we type in login up here, we can see that indeed it serves us the login page. So just a whole bunch of different routers. This resolve section has some authorization to see if we're logged in and redirect us to an appropriate page if we are, or if we're trying to access a page that we need to be logged in and we're not, it'll take us to the login page. But basically it just sets up the URL path and then what page to show for that corresponding URL. So that's the high level of Angular routing and single page architecture. And now we'll talk about Angular controllers, services, and directives, which are basically where the rest of Angular happens. So all of those are in the modules folder, and controllers are basically pages. So we have them in this pages folder. And we've already gone over this. We have in dev-test/test, we have these 4 files: an HTML file, a less file, which has our CSS, our JavaScript file, and then our test file. And we've already gone over these. Our HTML file, again, is just our layout. This is our styling, our CSS, and then our controller is our JavaScript. And controllers by themselves, you could write your whole app with just controllers, but that wouldn't keep things dry, which stands for do not repeat yourself. Good code is all about modularity and reusability, and so we want to make our controllers pretty slim and instead use directives and services to get a bunch of common code out of the way, abstracted out to functions that we can reuse. So the only difference between a directive and a service, the big one, is a directive touches the DOM, which stands for Document Object Model, and that just means the HTML, so it changes display. Services do not. They're just basically functions. So that's the big key difference, and services are a lot simpler because of that. So if we take a look at a directive, very similar to our controller. We have a JavaScript file, we have our less file, we have our test file. We do not have an HTML file. The reason for that is our HTML, we actually just code into our JavaScript file here in this template section. And there's a reason for that, but basically you're just going to concatenate HTML strings in JavaScript, and this will be your HTML. And we'll go over directives in depth in terms of actually how to write one, but we basically have our template file here, and then we have a bunch of code that looks just like a controller. It even is called controller. So you have your HTML here, and then you have just JavaScript code just like our controller code for the most part. So that's a directive, and the way we use a directive, you can see here in the examples usage, is you put it inside of an element and you reference the name of the directive. You'll see that in if we go back to our page, our dev test page, we can see that in our HTML file we have this ng-click. That's an Angular directive. So that's how you use directives. You just put them in your HTML and pass in any arguments. It's kind of like calling a function in JavaScript, but you're calling it from the HTML. And our last section of things are services. And again, those are just things that don't touch the DOM. So if we look at this storage service, we don't have any HTML because, again, services do not touch the DOM. And we don't have any less because same thing, less only applies to HTML, and we're not dealing with that. So we just have a JavaScript file and our test file. So we open our storage file. We have some Angular boilerplate, and then storages are basically just collections of properties and functions. Again, just so we can abstract away these things and use them across the app. This is how you can talk between pages, between controllers, which is kind of a common question. If you build something on one page and you need to then use some of that on a different page, whether it's user information or something else, one way you can do that is you can store that data in a service, such as store the user here, and then you can use it in as many controllers as you like. And in that way, you can save something in one controller and then use it in a different controller. So that is a service. And now we'll just go over how to use a service. So if we go back to our test page, again, controllers are basically where you use services and directives from. We go to our test controller, and we can see there are all of this list of items up here. These are dependency injected in services. So everything with a $sign in front of it is an Angular written service, and everything without a $sign, such as app HTTP and user model, are services that are custom written, not by Angular. And once you dependency inject it in, you can use the methods it has. So we injected user model, and now we can call user model.load from our JavaScript controller. So that is Angular in a nutshell. In the next video, we will go over Node JavaScript, which is our backend. In the last video, we went over Angular on the front end, and in this video, we're going to go over Node, which handles our backend. So if we look at our files, we have the app folder, and other than the configs folder, which we already went over, everything in here handles our backend, other than the src folder, which is our front end folder. So if we actually go to the root directory, we can see run.js, which is the main file, and that's why on the command line to start our server, we type node space run.js. So if we open that file up, we can see that this just checks our configuration to see if we're running, which environment we're running, which config file to use, if we're running a test environment or a regular environment, and then we require the app folder. And it doesn't say anything after this. It could say index.js, but by default, if Node just references a folder, it'll load index.js by default. So this will call index.js in the app folder, and it will pass in the config and this directory path. So if we go to that file, we go to the app folder, and we have index.js. This file will get loaded next, and it will require server, which // means the same directory, and if you don't have a .js, it will just infer it in Node, so this line will include server.js. That's most of what this file does. It sets a main process variable, and then it runs our server. So if we open up server.js, this uses Express, which is one of the most popular frameworks for Node, and Express 4 broke a lot of its subparts out into different modules, so the rest of these modules are other NPM modules that work with Express, and then some other modules here, HTTP and HTTPS for SSL, FS for file service, and Lodash is an array and object string library, and Q for promises. And then we have some database setup stuff. We handle real-time and handle cores, and we do a whole bunch of other stuff in this file. It's not super important that you get everything that's going on in this file. You're not really ever going to touch it, but we're just going to go through it at a really high level. So this is the main function that we call. We set up our Express app. We set some defaults and some parameters. We configure it here, decide if we want SSL or not based on the configuration file, and then down here at the bottom, we have this listen function, and server.listen is where we actually listen. And up here you can see the console log that you'll see when you're running it in the console, express server listening at, and it'll tell us what port and URL it's listening on. And that's the server file. And the next file we'll go into is our routing. So our backend routing, we use RPC. And so if you'll see this routes folder, there is this index file again, this API, and then RPC here. And again, you don't need to understand exactly how all of that works. So we're not going to go over all of those files in super depth, but we're actually going to go over building an individual route. So the first thing to know is there's a pretty cool interactive help file for this. If we go to our server, and we type in up here API/help, we'll notice that we get this interactive list of APIs. So we have auth for our login and logout and password handling methods, user, and we have search, read, update, delete, which are kind of the basic CRUD operations. CRUD stands for create, read, update, and delete. So RUD right here, and create is actually handled in auth in this case, but those are usually the four. And this is all interactive. We don't have any users right now, so this won't actually return anything, but if we click run interactive test, it'll actually show us results. So you can actually play around with this when you are writing API calls, or if you want to test things to simulate working with the back end without having to write a front end. So you can just interact with it directly. And you can see there are this documentation here of the different kind of parameters of what they do. You actually will form all of these, and where that happens is in modules controllers. So if we look at our user module, there's three files: our API file, our main file where kind of the main work happens and we interact with the database, and then our test file. So of our API file, if we look at RPC search, which is what we were just looking at, we can see it says info search users, and if you look back at the file, it says search users right here, so that's where it's pulled from. And then we have search string, which is a text to search for, and if we look back here, we have search string as a parameter, and the info is text to search for. So you actually will type in what the documentation will show up to be, and there will also be validation on this, so if you make it required, so none of these are required because there's no required field, but if we look at RPC read, this actually allows you to pass an ID or ID, so it doesn't have required, but one of these, here we go, user ID. So if you want to update a user, you have to pass in an ID, otherwise it will actually throw an error. So it handles both validation and documentation. So that's what the API file does. And then you'll notice it includes user mod, and then it actually calls that function. So user mod.read. So if we look at our user file, this is where all the functionality happens. If we go to the read function, same kind of documentation of the parameters, and then we set up a promise, and then we set the fields that we want to return, and then we use this crudmod.read, which abstracts away some of our database calls, and then we return a promise. So we'll go ahead and look at crudmod.read, because the last thing we'll go over is actually making calls with the database. So if we go to services, we have this CRUD module that handles these main database calls. If we look at this read function right here, we can see that we set up a query, and then we have db params.collection, so whatever you passed in, but let's say we passed in the user collection, it would be like db.user.find, and then whatever the query is, and then we return the records. So very similar, pretty much the same as making Mongo queries on the shell, which we can go over a little bit later, and you can read about if you just Google it, but you basically just have db.collection name, and then whatever you want to do, find, read, delete, update. And where these collections come from, if we go back to our folders, we can go back to app at the top, and you'll notice this database.js file. This file sets up our connection to our database. So we can pass in a URI if we want to connect to like a third-party database hosted, like in the cloud, such as MongoLab or MongoHQ or Compose. And we basically make a connection, and then we set up some databases to connect to collections. And these collections get pulled from DB schema, which is right below it. If you open this JSON file, this is all for documentation purposes. The actual fields don't matter, but the collections, the first level, those will actually get initialized in the database. So when you add things, you want to make sure that you put them in the DB schema file, at least the first level. And the rest of it is really good for documentation as well. That's pretty much the Node backend. We have, again, our routing that happens in our controllers is where we create our routes, and then in this routes and kind of the rest of the code, the index and the server.js is where kind of the magic happens to connect it all together. And then we interact with the database, and the backend pretty much does that. It's a bunch of API calls to interact with the database. And in the next video, we will go over some more specifics on MongoDB. In the last video, we went over Node.js, which was our backend. In this video, we're going to talk about Mongo. So we can access MongoDB from the shell in the command line if we just type Mongo. And we can do show DBs to see which databases we have. We're going to use Mean Company, which is the one that we've been working on. And then we can just type commands like db.user.find. And we can see that we have a user here, which I already created. And if we do db.user.count, we can see that there's one user. If we go to the site, we can create another user, and then we will see that user show up. So if we go to sign up, we'll say Luke2, create some password. We have this new user here, and now if we do count, we now can see that we have 2 users. And if you want to make the output look a little nicer, we can do find1 instead of find, and then it will output it a little bit better for us. Be careful when you're messing with the database directly like this. You can delete things and mess up the site, so you don't want to do this unless you know exactly what you're doing. But working with the command line here is very similar to working with it in Node. You basically type the same commands. So whatever you can do here for the most part, you can do and more in Node. So that is the M in the mean stack, which is MongoDB. In the next section, we will go over Angular directives in depth. In the last section, we went over all of the mean technologies. In this video, we're going to go over scaffolding out a new directive. So we're going to just type yo meanc, just like we did to originally scaffold out our whole app. But this time we're going to go to ng directive, which stands for Angular directive. We're going to give it a name. We'll just call it my directive for now. We can put it in a subfolder to organize it, but for now we'll just leave it blank in the main folder. We're going to use less, and we're going to run grunt. We can press A to overwrite all the necessary files. And now we should have new files created for us. So an src, modules, directives. We can see there's this new my directive folder. And in it we have 3 files, our JS file, a less file, and our spec test file. That's how to scaffold out a new directive. In the next video, we'll go through actually editing the directive. In the last video, we used yo to scaffold out a new directive, and in this video, we're going to edit that directive's HTML and CSS. If we go back to look at our new directive in our My Directive folder, we can open up the JS file, and we can see some boilerplate and some to-do items for how to edit our directive. We'll see example usage here of div myAppDirective and then closing the div. We're going to go ahead and copy that, and we are going to paste it in a page. We'll use our dev test page. So if we go to pages, dev test, open up the HTML file, and at the top we are going to paste exactly what we just copied. If we save that and we rerun grunt, then when we go to our browser and refresh, we see that we have this new my directive text up here where we pasted our code. And if we look back at our code, we can see in our directive, if we go down to the template section, we have this HTML variable that is set to div myDirective, just what shows up. We can edit that HTML. We can put edit here, and we can put a new line, just like normal HTML, line 2. And if we save that and we refresh, we can see we have those edited lines show up. And if we want to add some CSS or some less, we can give a class here. So we can say class, and it's important to namespace. So this directive we called my directive, and everything by default with the generator goes under the app namespace. So app my directive will be what we will prefix it with. And we'll just say cont for container. And we can save that. And then we can open our less file for the directive. So we go back to the directive, go to the less file. We can now say dot my app my directive cont, and then we can say color green. And if we save that and rerun grunt, when we go back to our browser and refresh, we can see that now our text is green. So pretty simple. It works just like a controller HTML and CSS. We have our less file and we have our template, which has our HTML, and we can edit it and the CSS, and things will show up wherever we have the my directive called from the HTML of any page. So that's how to edit the HTML and CSS of a directive. And in the next video, we will go over editing the JavaScript, the scope, and the attributes. In the last video, we edited the HTML and the CSS of our directive, and in this video, we're going to use JavaScript with attributes and scope variables to add some more dynamic functionality to our directive. So the first thing we can do is we'll go to our directive file, and again, that's going to be in our directives, my directives, the JS file, and we can see at the top we have this scope and attributes in this documentation. It's just documentation, so it doesn't actually matter, but it's always a good idea to document whatever you have. So let's say we want to add a new attribute, and we're going to call it custom text, and we'll say some special text. And as this note here says, snake case means you have a hyphen in between it, and that's how we're going to reference it when we're calling it, but we're going to use it as camel case when we reference it in the directive. A little confusing, but that's just how Angular sets it up. So now we actually want to use this custom text we added here. So if we go to our test file, we have our directive, and we want to actually pass something in. So let's say we have custom text, again snake case, not camel case, and we will say text1. And now we can save this, and we need to use this custom text in our directive. So in our HTML over here, we can make a new line, and we can say custom text and then attributes dot custom text. And it's always just going to be ATTRS. It's whatever you pass in here as the attribute, and then the camel case version of whatever we passed in. So if we save that file and we rerun grunt, we should then see that now we have custom text in our HTML. So if we go to our browser, we refresh, we can see we have this text1 that we passed in. Now, this is useful if we want to have multiple versions of our directive. Remember, a directive, the whole point of it is for it to be reusable, so we can use the same code over and over. It's kind of like a function in JavaScript, but for HTML. So we repeat the HTML over and over as many times as we want. So if we go back to our code in our test file, and we copy this, we can paste it, let's say 3 times, and I will put some line breaks in here. And right now they're all the same, but if we remove the attribute from the first one, and the second one will say text2, and then the third one will say text3, if we save this and rerun grunt, we will now see we should have 3 copies of the directive, and they will each say slightly different things, which is the whole power of a directive. So the first one we have undefined because we didn't pass it in. We have our text2 and our text3. So let's go ahead and fix this undefined here. So if we go back to our directive, we can say if not attributes dot custom text, we'll just set a default and we'll just make it blank. And that way, if it doesn't exist, it'll just be blank. So if we save that and refresh, we can see now it is blank. So these are attributes for a directive, and these are very useful if we have things we know that are static, that are fixed, that we can set ahead of time. But if we have a user property or something we pull from a database, we can't hard code it into the HTML. It's going to change. So that's where scope comes in. So scope is looks like an attribute when we call it, but we define it in the directive different, and we define it in the JavaScript different, and that's what differentiates an attribute from a scope property. So we'll say scope1 will be our scope property, and we'll say scope1 is what it references. And this will be defined in the controller, which is test controller here. So we're going to open up that file. So go to our test page and our controller, and we need to make a new property, scope.scope1. We'll set it equal to scope1, and we'll save that, and we will save our HTML file, and we can go ahead and get grunt running. Grunt only needs to be run if you change HTML or less files, but not JavaScript files. So in the my directive, we need to actually reference this. So it's a scope property. We'll add it to our documentation, just like our attribute. And it's going to be called scope1. Again, same thing, camel case referenced here, but snake case referenced in the HTML. And then we need to reference it. Unlike an attribute, we actually have to tell our directive to look for it. So we say scope1, and then we just say equals. We can talk about this more later. Their ampersand can be used if it's a function, but usually for a property we're just going to say equals, and that means we'll just reference it as scope.scope1 in the directive. So now we can use that just like any other scope property. So if we now say scope1, and now we will use it like a scope variable, so we can say scope1. And now if we save that and refresh, we now can see that we have scope1, and it's only in the first one because we only passed it into the first one. And again, the power of having it as a scope variable as opposed to an attribute is if we go back to our controller, we can change it in here and it will reflect in our HTML. And they're all the same right now, but again, if we were pulling from a database, we could have a different user and that would update the content dynamically. So it changes right there. So that's the basics of attributes and scope variables to add dynamic functionality to directives. In the next video, we will go over JavaScript controllers. In the last video, we went over attributes and scope properties of a directive, and in this video, we're going to go over the controller in the directive. So we can go back to our directive file in our directives folder, and then our my directive, open our JavaScript file, and you notice we have this controller. This functions pretty much exactly the same as the normal controller or of a page. So we can make scope properties like scope.scope2 equals scope2, and we can use that just like we had our passed in scope variable. And so we can say scope2, make it equal to scope2, and if we save that and we refresh, we can see we have this new scope2 here. And we can also make functions just like we can make variables. So let's make a function called emit_event, and we'll don't need to pass anything into it. And inside of here we will say scope.emit. We'll namespace it like always, and we won't pass it anything, but we'll just emit the event. And when it's clicked, we will console log just so we know that it happened. Directive emit event. And we need to trigger that function. So just like a normal controller, we can say make a div class equals button and ng click emit event, and now we should have a new button that when clicked should emit that event. So we have this new emit event button, and if we look at our console just to make sure that it's working, we click it and we say directive emit event. We can click it as many times as we want, and it works on all of them because it's defined in the directive itself. Now we are listening for it in the directive itself, which may not be super useful for an event, but we can also listen anywhere else, especially in the controller we called it from. So if we go back to our dev test page that is calling this directive, we can listen in here as well. So we can say scope.on at my directive, and we really should call it a specific event. We'll say event1 to distinguish it. And in here we can say scope.on at my directive event1, and we will listen for what it passes, which right now is blank, but we can always add to it. And here we will console log controller directive event. And now if we refresh and we click the button, we can see we get both of those to happen. So it's firing in the directive, but the controller is also listening for it as well. So that's one way we can talk back and forth between the directive and the controller. So we triggered something in the directive, and we can listen for it and then do something in the controller. And you can also go the other way from controller to directive with events. Another way you can do it, just like we passed in scope variables, we can also declare functions on the scope. So scope.func1 equals function, and we will have this console log func1 controller. And so now we declared a function, and we can pass that function in to our directive. So we'll say func1 again in snake case, and we will pass in our function. And if we save that and we go to our controller, we can now, or sorry, our directive, we can pass that in. So we have a new thing now, but instead of a string or a property, we're passing in a function, and we called it func1. We'll say custom function, and again we have to declare it in the scope, but this time it is going to be an ampersand, and we're going to make a question mark. The question mark makes it optional since we didn't pass it into all of our directive initializations. That could throw an error, so this says it's optional, and the ampersand means it's a function. So now we can make a new button here that is div class equals button, ng click equals func1, and now we're calling this new function that we passed in. So we can save that. We changed the HTML, so we're going to rerun grunt. And now if we refresh, we have this new button, and we can see that we're calling func1 in the controller. And if we click the second two, it doesn't do anything because we didn't pass in that function. But for the first one, since we did, we can click it, and then we're getting back to the controller. So that's a second way that we can talk in between the controller and the directive. So in this case, we are passing in a function with our HTML, and we're defining it in our controller, and we can do whatever we want once that button is clicked, and the button is actually created in the directive itself. So those are two ways that we can talk and pass things back and forth between the directive and the controller. And in the next video, we will go over writing automated tests for our directive. In the last video, we went over events and functions, the controller in our directive, and in this video, we're going to write some automated tests for our directive. If we go to our directive folder and we open the spec file, it's our test file, and it uses Jasmine, so we have this describe block up here at the top, and then we have some boilerplate here that sets some variables and adds our Angular module in, so we have access to things. We have this create element function that creates a bare bone directive, and we have a before each, and then we have this it here where we're going to actually write our test blocks. So if we uncomment this it block here, we can just make a bare bones create elem, which just creates our basic directive, and we can make an expectation, and we'll just make something that's false up front. And before we save that, we're going to run a watch task that will actually wait for the files to change and then automatically rerun the test. And that's just grunt dev-test. So we can see here it says waiting right here. So now if we go back and we save this, and we go back, we can see that it noticed that we changed a file and it automatically ran tests, and it expected 0 to be 1, which was the expectation we had, and 1 failed. So that seemed to work. So we can now make it be 1 to be 1, and we should see it pass now, and indeed it does. But that doesn't actually really test our directive. So let's write a real test. So let's look at our directive file itself, go back to the JavaScript file. So in the controller we can test that scope 2 is set properly, and we can test the events. We can pretty much test everything here. We'll just start out with testing that scope 1 gets passed in, this new property that we added in here. So in our spec file we'll change this to be it should have a scope scope1 property. And then we will write that into our HTML. So over here, we will say var HTML, and we will say div app my directive, and we'll say scope1 equals scope1. Close that. We're going to have to shift to double quotes here. And then we can pass that in here to customize the HTML that's rendered. And now we can say we want to make sure that that actually gets passed in properly. So we have access to the directive scope right here with elem scope. And so we want to expect elem scope to be, first we need to define it. So we say scope.scope1 equals test scope1, and we want it to be equal to test scope1. And I'm going to make it fail first. That's generally a good practice to make sure we don't get a false positive. So, we need to make sure that this points to our property. So if we save that, it should fail. So expected test scope 1 to be test scope 1 with an extra 1, which is exactly what we expected to happen. If we now fix it and save it, we can now see that it passed. So that's a really basic use of tests. We can test the rest of the things. We can also test if scope 1 isn't passed in, that it doesn't exist. We'll go over full test coverage and how to do that later, but this is just a basic example of how to write a first test for a directive. Again, most of this is boilerplate that you won't have to touch. It's generated for you, but that's how to write your first test. And in the next section, we'll go over creating new controllers and services. In the last section, we went over Angular directives. In this video, we're going to use Yo to scaffold out a new Angular controller. So we'll type Yo mean seed as before, except for this time we're going to select ng route instead of ng directive, and we'll just call it my page. We'll leave it in the main folder, run less and grunt, press A to overwrite the files, and this will create our new controller files for us. Also can be called a page or a route, kind of interchangeable naming wise. So if we go to modules, pages, we will see we have this new my page folder, and inside this folder we have our 4 standard files: HTML for our layout, our less for our styling, our controller for our JavaScript, and our spec file for testing our JavaScript. So that's how to use Yo to scaffold out a new front-end controller, and in the next video we will look at behind the scenes of what actually happened with the generator to create these files. In the last video, we used Yo to scaffold out a new front-end Angular controller. In this video, we're going to look at behind the scenes of what that actually did. So if you've already committed your changes, you won't see them when you type git status, but you can look back at the history with git diff, and then if you do the @ and then 1, it will go back 1 change. If you just want to see the stats, you can type --stat, and this will show us the changes that were made. So we edited app.js, which is our routing file. We added a new set of sections to build files modules to include our new page we created, and then we actually created those 4 pages. So we'll take a look at app.js and build files modules. So if we look at the diff again without the stat, it'll actually show us changes. So in app.js we can see there is a new route provider section that looks at my page, and it's going to serve the page that we created. So if we go to a browser, we can change our URL to say my page, and it should show us our new generated page. And indeed, we have my page right here, which is the default that starts with our new page. So that's all that happens in app.js. If we keep on pressing enter, we can go down to build files modules, and we can see that all that happened here was it took the 4 files we created and it added it in to a new section, so those files will actually be included by our application. so we know how to reference them and use them. And that's all that happened there. And the rest of the files, we actually just created all of the new pages themselves. So again, if you look at the diff with just the stat, we can see we changed 2 files and we created 4 new ones. And that's really all that happens behind the scenes of the Angular controller. In the next video, we'll actually edit our new pages to change our default controller. In the last video, we looked behind the scenes at what the ng-route yo scaffold built out for us, and in this video we're going to actually edit our new controller page to edit the functionality. So if we go to our new folder, the My Page, in the modules pages directories, we have our 4 files. We can look at our HTML and we see that it just says My Page by default. If we open the controller file, we can add some scope properties just like any other controller file. We'll just make an array of items, and we will make it be an array of objects, and each object we can say have a title. So we'll say title 1, and then we'll make another one that's title 2, and we'll do 4 of them. And we can save that, and then in our HTML we can say div ng repeat equals item in items, and then in here we can say item.title. And ng-repeat is just a built-in Angular directive. You can Google it and learn more about it, but basically it just is like kind of like a for loop for HTML. It'll go through each item, and then it will, by saying item here, it'll give you access to it. So these just match. So then you can do item.title. And if we save that, we can run grunt, and then we should see those items show up in our browser. So we refresh on My Page, and indeed we see these 4 items. And we can edit our less just like any controller. So if we open our less file, let's say we want to make them larger. Of course we want a namespace, so we'll say My Page item, and we'll say font size 20 point. And if we add a class here, class equals My Page item, then if we rerun grunt, we should now see that our items, each individual one, will get that class, which will make the font size larger. And there we go. So that is how to edit a controller. Once it's created, you can edit it just like any other controller. And you have your HTML, your less, and your JavaScript, and you can keep building it out to customize and build your page. In the next video, we will go over scaffolding out a new Angular service. In the last video, we built out our new Angular controller, and in this video, we're going to use yo to scaffold out a new Angular service. So we're going to type yo mean seed just like before, but this time we're going to choose the ng service module. And we'll just call this items list. We'll abstract out our logic we just built into a service. And again, you can put it in a subfolder. We'll just leave it at the top level. You can use a factory or provider. You'll almost always choose factory. So we'll pick factory. We'll run grunt, overwrite the files with A as usual. And this will build out our new set of files, which we can then look at. So modules, services, we have this new items list folder, and in it we have our JavaScript file and our test JavaScript file. So that's how to use yo to scaffold out a new Angular service. And in the next video, we will look at behind the scenes what yo did to build that for us. In the last video, we used yo to scaffold out a new Angular service, and in this video, we're going to look at behind the scenes what that did. So as before, we can type git status, and if we have already committed our changes, then we can do git diff and look back 1 diff, and we'll start with stat to just see an overview. And we can see that we changed build files modules, and we added our 2 new files. So even simpler than the directive. So in build files modules, we did pretty much the same thing as the directive. We just added a new section for our service. So we can see here we have the name of it, and then our JavaScript file and our test file. And the rest of the changes are simply adding our 2 new files. And that's it. That's behind the scenes of what happens to build a new Angular service. And in the next video, we will actually edit our new service to make it do something useful. In the last video, we looked at behind the scenes of the ng service Yo, and in this video, we're going to actually edit our new service to make it do something. So if we go to our service files in the items list folder, we open up our JavaScript file. Again, we have some boilerplate here, and we have example usage of how to use our new service. And we have public methods and properties, and then we have private ones. The private ones, as the documentation says, will not be accessible outside of this service, but the public ones will. So we're going to make an items list, and this items list is going to have two functions. It will be able to save items and load items. So for saving items, it'll take items and then any optional parameters. And it will then take those items and it will save them somewhere. Now we have functions and properties, so we're going to make a property here, kind of like this example documentation shows, that will be items, and we'll initialize it to just an empty array. And so save, we will use this, which will refer to this object itself, and then this dot items will refer to this guy right here. So if we do this dot items equals items, that will just save our items. And now we'll make a load function that will take the items, or it will basically return the items that we already have. So make that a function, and we will say return this dot items. Now if we want to initialize those items, let's say they don't exist yet, we can say if not this dot items or this dot items dot length is less than 1, then we know that it hasn't been initialized yet. We can create it. We can say this dot items equals, and then we can actually create it. And so we'll go back to our controller file and we'll take these right here that we initialize, and we'll actually put that code in here. So now we have these set of items, and if it doesn't exist, it should create it for us and then return it for us. So now if we save that, and we can now change this, we can comment this out. And instead of setting scope.items into a hard-coded value here, we can dependency inject this new service, app items list, that we created, which again we can see in the documentation boilerplate. It has an example here, app items list, and then we pass it in here as well. And then we access properties on it. So put it in both places. You could name the second one different, but you always want to pretty much name it the same to not get confusing. So now we can say scope.items equals app items list dot load. And now if we refresh in our browser, we should see the same thing, but now it should come from the service. And the way we can make sure that we actually are from the service, since we didn't really see anything change, is we can add a fifth item in here. And so put a fifth item, save it, refresh, and sure enough we have a fifth item. Now in this load function, we're defaulting to creating these items if none exist. We can also use the save function to save our items before we load them. So we can take these right here that we originally had, our 4 items, and we can say var items equals, and then paste that there. And then we can say app items list dot save those items we just created. And now we will save them and then load them, so we should get back to 4. So now if we refresh, this 5 should go away. Sure enough, we have the 4. So that's a really simple example of a service. Again, the whole point of having it and dependency injecting it in is for reusability, just like a directive, except for a service that does not touch the DOM or the HTML. So here we only are dealing with JavaScript, and it makes it easy for us to then use those same items in a different controller if we wanted to. So that's how to create and edit our Angular service. In the next section, we will go over Angular unit testing and code coverage. In the last section, we went over making a new Angular controller or module. In this video, we're going to go over the basics of how a Angular controller test is scaffolded out and looks. So if we scroll to our website and we open up our dev test folder in the front end, which is in Pages dev test, we can open the spec file, and we use Jasmine, so we have describe and it blocks, and these just group your tests and make the total number of expectations and test failures or tests that will run and either fail or pass. And here we initiate some variables for controller and scope. And then we have these two before each statements, which, as the name implies, these will execute before each individual it statement. And so we can have multiple it statements in here, and then each one will run a test, and before each it statement, it'll do the before each, which in this case injects our Angular module right here, the whole My App module, which has all of our services and other modules in it. And then this injector section, which creates a new scope for us and actually creates the controller. This line right here initiates the controller and passes in scope to it. And then this is just a placeholder right now for the test to run. And this is where we will actually add our tests. Tests can obviously get a lot more complicated, but this is kind of the basic syntax of how they work. And in the next video, we will actually write some real tests. In the last video, we went over the basic boilerplate of an Angular controller test, and in this video, we're going to actually write some tests. So if we go to our dev test page that we've been using, which is a controller, we can open our spec file, and we can actually write some real tests. So we're going to look at our controller, and all of these things can be tested. We're going to start just by testing that scope.func1 exists and does what it's supposed to do. The first thing we need to do, though, is remove these console logs. It's hard to access things unless they're on the scope, and in general you're not going to have console logs in your code anyway. That's just for debugging. But for the purposes of this video, we're going to make an array that is called scope.log that will just keep track of our log messages so we can access them in the tests, and we'll make a function called logit that will take the text we want to log and optionally some parameters, and we will have this function do our console log for us, so it's all in one place, and we'll say logit, and then we'll say plus the text that we wanted to log, and then we will push to that array that we've been adding to the text, and again that's for testing purposes. So now we can take all of these console.logs and we can replace those with calls to the logit function. We will just do that for all the console logs. Probably should have just done a global replace, but we're pretty much done now. So now, if we call scope.func1, we should get this logit function to be run. So if we save that, we can test it out. So if we refresh this page, and then we look at our console, click func1, and we have this logit in front. So our function is getting called right there. So now we can actually use this scope.log in our test. So we're going to say it should have a func1 function, and we want to test that log is getting added to. So we would say scope.func1. So we're just going to call it, and then we're going to say expect scope.log, and then we want to get the scope.log.length -1, the last item in the array, .2b, and we'll just start with saying, so when we call it, it should say func1 called. So we will put that in there, and we'll just add an extra 1 so it fails the first time just to make sure. And then we need to go to our console and watch for our tests. So if you remember, the way to do that is grunt dev test, which is our watch task that will automatically rerun tests whenever we change a relevant file. So we can see that it's waiting. And now if we go back and save our file, we will see our tests are running for us. And we have one failed, and we expected func1 called to be func1 called 1. So that is what we expected, and now we can get rid of this extra 1, and if we save it, we go back to see our test, we should pass now 96 of 96 success. So that's our first statement, and let's write some more tests. So the next thing we can do going down this file is we can test that this user model is being loaded properly with this scope.user value. So there's kind of two things to test. One is to see if the user model isn't set, it should not exist, and the second is if the user model is already saved, then it is loaded properly. So the first one would be it should have no user if not saved, and for this one we will just say expect scope.user.id to be, we'll start it out with true because it actually should be false. Again, make sure that our test fails before it passes. So expected false to be true. So now we put it to false and save it, and it'll be run. So that's by default, the user model will start false for the ID. So now let's say it should have a valid user if saved. And for this one, we are going to make a user. So var user equals, and we'll just worry about setting the ID right now. So ID user ID 1, and then we want to save that. So user model has a save object where we can pass in a user, and in order to use user model we have to inject it. So we see up here we're injecting certain things. So we're going to create a new variable for user model, and then kind of following the same syntax, the default is to put underscores for the injection and then set your variable we declared above to that, and that should give us access to that module. So now we should be able to do a user model.save, and then once everything runs we should now be able to say expect scope.user.id to be user.id, so what we set it above. So we can save that. Now if we look back at our tests that are running, we can see we have 98 of 98 success. And again, to just test that it worked, we can just say something else here and run it, and it should fail, and we expected user ID 1 to be false. So that worked. And the last thing we'll show in this video is, just like any other code test, we can make functions and abstract away things to keep our code dry. So we may want to have the user set for other tests, more than one test. So instead of copying and pasting this code into every if block, we can abstract it away. So we can copy that code, and up above here we can say function set user model, or just set user, and the user we want to set, and well, we'll just say params for now, we'll just default it, and we will paste that code, and that will save the user. And now we can just say set user right here, and now if we save that we should still pass, but the difference is, oh, we failed one. Oh, so we don't have access to this user variable anymore because we put it in the function. So we can either take this and move it outside the function, or we can just hard code in user ID 1 here. We could also have the user function return the user that it sets, so then we could use it here. So there's a couple different ways that you could do that. Again, just kind of typical coding best practices. For now, we'll just hard code it And so if we look at our tests again, we can see we passed our tests. So that's an example of writing some tests for a controller. We just wrote 3 pretty simple tests here. Again, you can abstract things into functions. You can put things in before each. Kind of the same stuff for best coding practices anywhere else applies to a test. In the next video, we will go over code coverage for our tests. In the last video, we wrote some tests for our Angular controller. In this video, we're going to go over how to create and use code coverage for those tests. So we can run our grunt dev test task again to watch our tests. And if we open a new tab, we can make another task that is actually going to make code coverage appear. So if we go into our directory for our site, we can then write grunt dev karma cov, and that will actually make coverage appear so we can view it. And again, if you want a refresher of what the grunt commands are, you can always go to the root of the folder and go to gruntfile.js, and it has a list in the documentation of all the commands. And as you can see, grunt dev karma cov is for making unit test coverage, and the rest of them are documented here as well. So now that both of our watch tasks are running, which we will confirm, so we have both of them are running and watching, we can make a change to a file. So just add a 1 and delete it and save it, and that should trigger them both to run, and they both are. And if we then go to our folders, we'll see this src, our front end folder. We just had this new coverage Angular folder appear, and inside of that we have this phantom.js folder, which I'm just going to copy the name of it. We're going to navigate to this folder in a browser. So if we go to our Chrome and we go to localhost 3000 src, because we always start from the root folder, so into src and then coverage Angular, and we can see I've already accessed it, so here it is right here. If we press enter on that, we can see a list of all of our files with the code coverage and overview of statements, branches, functions, and lines up here. And we can click on an individual file and we can see the coverage for that file. So we have the My page right here is one of the pages we created. We can click on that and get a summary of that file. We can click on it again to actually see the file itself. Lines that are green are lines that we have covered, and lines that are not green, that are yellow or red, are lines that have not been accessed. And we can go back and we can see a page that has higher coverage, like the header, again is mostly green, and we have some that are not covered. This I right here means that the if path, if you hover it, it actually shows up, hasn't been accessed, but the else has been. So when you're going through and writing your files, this is a good way to kind of make sure you're at least touching all of the different lines of your code. But again, note that just because you've accessed all the lines of your code doesn't mean that it's foolproof or great code. Still have to write expectations in the test to make sure that it actually does what it's supposed to do, not just that it runs. And even then, it's not perfect, but it's definitely a good place to start to have your code well covered. In general, best practice is having at least 80%, which is what turns it green, and then obviously if you can get up to 90% or 98 or 99% or even 100, that'd be great. So that's the basics of code coverage, how to see it, and then you'll just go through and keep on adding tests so you get your code coverage as high as you can get it. And in the next video, we will go over Angular service test. In the last video, we took a look at code coverage and how to create it and view it. And in this video, we're going to write some tests for a service and get up to the green 80% or more code coverage for that file. So if we look at a list of all of our files again, we can sort them, and we can see that there are these 4 files that don't have great coverage, but the rest of them start out high on the mean seed generator. And it's this item list service that we created, the page that we created, and then the directive that we created, plus this other file. It starts that way. So we're going to go ahead and write a service test. So if we click on this items list service that we created, we can click on it and see our current test coverage, and we can go ahead and increase that coverage. So we will open up that file, which is in the web folder, src, and then modules, services, items list, and we'll open the JavaScript file itself and the spec file. And right off the bat, we can just uncomment this blank default line, and that will at least get it to run the function itself, which should bump up the coverage right away. So we can see it's 12.5, 12.5, and once we have this run, coverage is run. If we refresh this, we can see it goes up just because we called it. Now, we didn't really test anything, so again, that doesn't really help us, but just an example of the difference between code coverage and actually writing a real test that makes sure your functionality works. So first thing we'll do is we'll make sure that it saves items. So if we look at our JavaScript, we really have to test two things, that it saves and that it reads. So first we'll do save. It should save items. And so we have this app items list as a reference to our service, and so we'll do var items equals, and we'll just say 1, 2, and we will say app items list dot save items, and then we'll say expect. Well, so we actually want to test that it actually worked. App items dot save actually takes this dot items and sets it to whatever we passed in and returns true. So we want to actually access this items and check that it works. So we would expect app items list dot items sub 0 to be 1, and we'll just make it fail at first, ensure we don't get a false positive. So we'll look at our tests. We'll look at the first one. So expects 1 to be 1 with an extra 1, which is accurate, so we can make it pass now. And when that code coverage runs, it will update. So we can go ahead and look at this once it's done, which it is, and we can see we already made it to the yellow, and our save function is now covered, it's green, so we went into that. So now we can do the read function, so we can say it should read items, and so for this we want to take a bunch of items. Well, we can just, it does set defaults for us, so we can just call app items list dot read, and we can say var items equals and save that. And to make an expectation to make sure it actually works, we have these default items, and so we should expect this dot items dot title to be 1. So we can say that expect items sub 0 dot title dot to be 1, and we can save that. And now if we refresh over here, we can see that we're in the green and we've gone to the read function, we just haven't gone in the else. So it's setting the items for us. So in order to do that, we can now make another statement. It should read items with existing items. We can actually set the items for calling the read. There are a couple different ways to do that. We could actually use the save call up here, or we can just set them directly. It doesn't really matter. There's kind of pros and cons to each approach. So we'll just say app items list.items equals 3 and 4. Now, if we read, our item sub 0 is not going to even have a title property because we just made it strings, and we're going to expect that to be 3. We'll leave it at 1 now for it to fail. So we'll check this out. 3 to be 1, which is what we expected. So if we put it back to 3, which is what it should be, we save that. That will rerun. 100 of 101 passed, and our coverage has run. We can see we are at 100% coverage. So that's how to write simple tests for a simple service. And we got 100% code coverage, and we have at least one expectation in each if statement, which is good because, again, we could get rid of the expect statements and still have 100% code coverage, but it won't guarantee that our code works. So it just means that we ran all the lines. So it's really important to have expectations in addition to having high code coverage. So that's how to write tests and get high code coverage. In the next section, we will go over adding a front-end Bower module to your application. In the last section, we went over Angular unit testing and code coverage. In this video, we'll talk about searching for and adding new modules to our front end. Bower is our front-end package manager, so if at all possible, we want to get our modules from Bower. So if you type in Bower search in a web browser, you'll see Bower search will come up, this GitHub repo, and there's a link at the top here for bower.io/search, and then in here you can search for different packages. Now there's a whole bunch of packages, and you can see a bunch of the popular ones, including Angular, here at the top, and you can sort them by stars and updated. We're just going to do a search for a crop directive. Let's say we want to crop a picture, and we can sort by stars with the most at the top. And the updated is also important because in general you want to pick a module that is actively maintained, so that means it's been updated relatively recently, so 10 days or a month is good. Sooner is obviously better. And we're also going to type Angular in here because we're looking for an Angular specific directive. There's a lot of modules out there for a bunch of different, some of them are plain JavaScript, some of them for other frameworks. Getting one that actually is built for Angular is going to make it a whole lot easier. So if we search both of those terms, we'll see these Angular ones, and we'll just open up the first two, and we can see this one may be more than we need. You also want to get something that just does what you need, otherwise you're adding a bunch of code that you won't be actually using. And so you just want to kind of look at them and then pick one that you think is going to fit. So if we look at this first one, some of the things you want to look for is make sure it's supported in your browser, that they have example usage so you can quickly get started. And one of the things I always look for is dependencies. So you want to know what you're actually going to have to include to use this. One important dependency is jQuery. That is a very common dependency, but it adds a lot of code bloat because it's really large, and Angular has a small JQLite version already. So one of the things I always look for is one that does not include jQuery. And so in this second one, we see it lists the requirements out for us, and it doesn't have jQuery here. So that's something that I look for. And if we then look at the usage, it has an example, and it also has example code right here on this page, and we can see that it just uses Angular and then the module itself. So it's pretty straightforward, and that's always really nice. So we're going to go ahead and try this one. We have this example usage right here. So we'll go over actually implementing this one in the next video. In the last video, we went over searching for and adding new modules to our front end. In this video, we're going to go ahead and add in this new module we decided to use via Bower. So if we scroll down here, we can see that it has the installing section. In general, there are 3 steps to add a Bower module to our Angular app. We need to download the files. That's step 1. Step 2 is to include the files, and step 3 is to tell Angular about our module. So step 1 is to download it. You can download it without Bower, but we're going to use Bower because that is a better solution in general. So it has this example of Bower install ng image crop. That will work, but it won't actually add it to our Bower necessarily. So we're actually going to just edit our Bower file itself. So if we go to our root folder, we have this bower.json file. If you go ahead and open that up, it has a list of these dependencies, and convention is generally to just use latest for Bower modules. So we can go ahead and just add ours in. So ng image crop is the name of it, and then just say latest, and then we'll double check we spelled it right. ng image crop, make sure capitalization is correct, and that looks good. So now we will say Bower install, and now that there's something new in there, it should actually install ng image crop for us. So we can see that it installed it, and it tells us right here where it put it. So src Bower components ng image crop is where it's located. If we look at those files, we can see in src Bower components, we do indeed have this new ng image crop folder with the files in it. And so now if we go back to our documentation, we are told to add the files. That's step 2. So Angular we already have, and then we're going to add ng image crop and make sure that works. So if we go back to our new file, we see that ng image crop, which isn't in the main section, so we'll look in the compile section. So we have minified and unminified. Generally you want to use minified because that's going to be smaller. So it seems to have a style sheet and a JavaScript file. And if we look back at our documentation, those are both included there. So we're going to use these two files. So we have the path up here, and we're going to add them to our build files modules, which is how we include files in Meanseed. So open up build files modules, and then we have a section that says Bower, and we have a section for minified components. So inside of the JavaScript, we're just going to add a path to our new files. So ng image crop, and then we have inside of that, we're in compile, and then inside of compile, we're in minified, and then ng image crop. So minified ng image crop .js. So we just included that. We'll go ahead and copy that because it's going to be similar for our CSS file. So we can see in our file section we don't have any CSS section, but we can go ahead and add that. So if we type CSS, we can make an array just like JavaScript. And so we can paste this here. We will put CSS and make sure we have our quotes. And now we should have included both of our files. So if we save that, we can then rerun grunt, and that should then add those files in for us. And the way we can check that is we can go to our index.html. So if we go to the main section of our front end, we can go to index.html. We can search for image crop, and we do indeed have this image crop file. Our CSS is included, and if we search again, we do indeed have our JavaScript. So we did include our files. So now we can go back to our next step, which is adding it to Angular. So as it says, we want to add it to tell Angular that this module ng image crop we're now going to include. So the way we do that is in app.js. So if we go to common.js, app.js, we have a list of these modules here, and we can just add ours at the bottom here in single quotes. And when we save that, we should now have done all 3 steps, and now we can actually go ahead and use it, which we will go over in the next video. In the last video, we went over implementing add new module, and in this video, we're going to actually use our module that we just included. So usage is going to vary by each individual module, but in general, directives you're going to use by putting in the HTML and adding some JavaScript in our controller potentially for the options, and services you're going to add just by dependency injecting it into like a controller or directive and then using it. So this is a directive, and so as it says, we add the image crop directive, and then we pass in some properties. So we're going to actually just go to the example code. We already included our files. We don't necessarily need this, I'm not sure. We'll add that in later if we do to the CSS. We'll just go ahead and add it in. So we'll put it in our test file. So we're going to add this directive to our our test page we've been working with, so dev test test. We'll open up our less file and we'll copy this in. And then we'll go back to the example usage, and we have already added it as the module. We have our controller, so we're going to copy this controller code right here, and we're going to put that in our test controller. So open our test controller, we'll just go ahead and put it at the top. So here's our new code. And now we'll go back to the documentation, and we have this HTML here that we will also go ahead and copy. And that's generally a sign of a good module. Third-party code is if you can actually just copy and paste and get it working with the default settings. We'll see if that works here. So this is the HTML, so go to the HTML file. Again, we'll just kind of put it at the top. For now, we'll just comment out the rest of this code just so it doesn't get messy. And in general, you're going to put it in a new file and keep things more clean, but this is just for an example. We'll use the same file we've been working with. So we'll save all three of these files, our less file, our controller, and we will run grunt. And if the documentation works and we copy and pasted properly, it should just work. So now that grunt has run, we can go to the browser and we can go to our site, and we have this choose file option here, which looks good so far. So indeed, we did get an image, and it has our cropped version here that we can move around, that automatically gets updated. We can make it bigger or smaller. So this looks like a really good directive, because just by copying and pasting the example code, we got it to work right away. So now you can go back to the example usage that was here, and it talks about options. So now you can actually customize it and see what you want to use. But in general, that's a really good directive because it worked right off of the bat real simply. So that's how you include a directive module. If we had a service instead, again, we have these dependencies here, dependency inject services. If you downloaded a service, you would install it the same way. You would tell Angular about it, and then up here you would just, say my service, whatever you downloaded online, and then at the end here you would say my service, and then in the code itself you would just type, my service dot whatever function that service had. Obviously it's going to depend on the service, but that's the only difference between using a third-party service and a third-party directive. So that's all for this video. And in the next section, we'll go over how to search for and add new NPM backend node modules to our app. In the last section, we went over adding a front-end Bower module to your application. In this video, we're going to learn how to search for and add new NPM backend node modules to our app. So there's two primary places you can search. One is NPM itself, which stands for Node Package Manager. So if you click on that, it will take us to the NPM site where we can search. The other one we can use is called Nipster, and that will add a GitHub rating in as well for when we're searching. So if we click on this link here, we can search in this box and it'll combine NPM and GitHub. And in this case, we're just going to search for cron to do like a cron job task that we'll add to our site. And we can see here, it's not always perfect. These are all linking to the same GitHub repo. But if we go to NPM, we can also search for cron. And if we search that, we will get results as well. So here we can see on NPM results, and we can see how many downloads were made in the last week. And that's a pretty good tell for how good the app is, or how good the module is, by how popular it is. So you can see that one, unfortunately there's not an easy way to sort on this one. That's why Nipster can be good. You can kind of use both of them. But we can see pretty clearly that this one has more. And it tells us right here the version is 1.0.5. That's the current version. So as before, when you're looking for a front-end module, when you're looking at the module, you want to see that it's actively maintained and how popular it is, and you want to spend a little bit of time making sure you get a high-quality module that you're including in your app. And in the next video, we will talk about npm cron module. So now that we have found the module that we want to use, we can click on it in npm and we can see the name of it and the install instructions over here. So npm install cron. As before with Bower, we can run that command, but that won't save it into our package.json file. So when we push it to the repo and other developers using it, they won't get the module. So you can type a command. If we go to our console, you can do npm install cron, and then you can do some hyphens like save dev, and that will automatically add it to package.json. I just like editing package.json directly. It doesn't really matter. So if we go into our website and we see there's the package.json file, you can just add cron at the bottom here and type the exact version that we want to use. If you go to semver, stands for semantic versioning, if you just Google that, for npm it will, this is kind of what npm follows in terms of versioning. You can put tildes in front of it to make it match any version that is about that one, which means it won't change a major version. I think npm has an example. So here, if we look at the node sem version, it has some examples of usage. So we have less than, greater than, equal to, and then there are tildes down here, which you can use an X if you want it to be any version greater to, or you can do tilde range. I just use the exact one and then just make sure to keep that updated. So the numbers are just the exact version. That means it will only install this version, and if a more updated version is available, there's a grunt tool called dev update that will check for you, and then you can update them that way. So I just use it directly, but it's up to you. So once we have that updated in package.json, we can save that, and then if we go back to our console, now if we run npm install, it should find that new package and install cron for us. So we can see that it installed it. It installed cron, it installed it at this version 1.0.5, and it tells us where it put it, and now we have our new module and we can use it in the next video. Now that we have our npm cron module installed, we can go ahead and use it. We're going to use it as a service. So if we go to our backend, which is app, and then modules, there's a services folder. And if we copy any one of these existing service folders, we can paste that in here, and then we can use cron, and then open that up and rename the file as cron. And then we can open this up and basically blank it out, but keep kind of the syntax. So the syntax we'll use is, we have the name of it, which we're just going to call cron.prototype, and then the name of the function here. And we're just going to call this, we'll make a job that's just called test run. And it'll just take any kind of parameters we want, clear this out, and then we'll just clear out everything else down to the bottom, except the module exports line, which that's the line that will actually make it available. So we'll call it new cron, and then this line, which actually declares it, and then our documentation can clear here, and we can add that documentation later. So basically, we declare the function, we create a function that we're going to export, and then we actually export it. So inside of here is where we can actually write our function, and as before, we're going to look at the documentation. So if we go back to npm cron that we installed, we can scroll down and we can see our basic usage. So the first line right here is requiring it. That's the first step to use a module. So for backend modules, up here at the top, we're going to say, we're just going to require it, and we don't have to give a path. We can just say cron, which is the name of the module for npm, because when you do an npm install, it basically makes it available in the right place. So that's our first line. We're actually requiring it, and now we can use it. So we can then copy this next usage, which will actually start a cron job. So in our test run, we can just paste that. And as the the console log right here says, the way a cron job works is you basically tell it how often you want it to run. And in this case, it's going to run every second. If we change this to be /5, it'll run every 5 seconds. And you can look at the documentation here, different examples. So as this says, it'll run 11:30 every weekday. And so there's a bunch of examples of how you can use it. But for now, we'll just run it every 5 seconds. So this will actually make this available. But now that we've written it, we need to call it. So we're just going to, for the sake of this example, we're just going to put it in our main entry script. So if we go to we have run.js, which starts everything going, and then we have our server.js, which is in the app folder. So in server.js, we will require that service, and we can do that kind of just like we do the real-time module include. So we have this built into the mean seed as a path builder, basically, that we can get to our services directory. So if we put it here, we can say cron mod equals, it's in the services directory, and it's just cron.js. And now we have it, and now we can do cron mod dot, and then whatever we want to access. And so we have a test run function. So we can say dot test run, and that doesn't take any parameters. And then if we save that, if we run our server, and if your server was already running, you'll have to rerun it because we changed the backend. Now when we run node run.js, oh, so we got an error here for cron because we picked a time zone from the documentation, and it says we can't. So we're just going to blank this out and try again. Apparently I did my syntax wrong, so we'll put it back to the asterisk for now. And now we see this message every second, as it implies. And so now we have our module running. And that's very basics of how you add a new module. So again, first we updated package.json, which is in our main folder, and we added it in and then ran npm install. And then once we did that, we made a new file, and we required that, just like the documentation of that particular module. And then we pasted in the example code for that module, and then we actually included this file. In this case, we did it in server.js, but we can do it elsewhere. And now we have a cron job running for us that we can see. In this case, it's just outputting a message every second. So that's how you include and use a Node module on the backend. In the next section, we're going to walk through creating a new backend Node API controller. In this video, we're going to walk through creating a new backend Node API controller. The first thing we're going to use is the Yo mean seed to run our backend generator to scaffold it out for us. And then we're going to select Node controller, and we're going to give it a name. We'll just make a product controller, let's say. So we'll just say product. And we have two options, CRUD or basic. CRUD stands for create, read, update, delete, and that will give us an API backend that will already have those 4 operations built in. So it's good to use when you're making like a new collection. And basic will just give you a bare bones one. So we'll go ahead and make a CRUD one. And we can press A to overwrite the files. And now we have our new files created. And in the next video, we'll go over what those files are and how to use them. Now that we've created our new controller with the Yo mean seed generator, we can go to our files, go to app, which is our backend, modules, controllers, which is where our new file will be, and you can see we have a new product folder here that has 3 files in it. We have our API file, which is going to actually make the connection that's going to give us access to the code itself. So this is like the API route connector. And then we have product.js, and that's our where most of the work is going to happen, where we're actually going to write our different calls to connect to the database and read products and save products and delete products. And our test file, which is going to be for automated tests. So these are the 3 files that are created. The other files that were edited, we can see, just like in the other front-end generators, we can type git diff and then 1, and that will show us the difference between our previous commit and our current commit, since I already committed after running the generator. So you can see we changed DB schema, which we'll go through at the end. We added our 3 product files that we just went over, and we updated these other 3 files, index.js, our API help file, and then our spec file. So we'll go through these 3 pretty briefly. So if we just type the same thing but without the hyphen stat, we can actually see the differences. So DB schema, we're actually just adding a blank collection. That'll be a filler because it'll be different for each different schema. And then we have these product files, which instead of running through all of them, we're actually just going to do the difference of the particular file we want. So if we do the hyphen stat again, we can see that there are these 3 files at the bottom here that were changed. So if we do app routes, that will only show us the files that changed in that section. So here we have API index.js, and the green is all of the added stuff and the red is the deleted stuff. A lot of times you'll see deleted lines and then added lines that look the same. That just means it moved, and that's kind of how Git tracks the change. But basically we added a new API hook and then a new API module here. And you don't really need to understand this. The generator will do this for you. But we're just going through kind of behind the scenes of what the generator does. And then in our help file, we simply add a new link for API product help if we want to see the API routes for this. And that's it for those 2 files. And then the other file that we haven't gone over yet is this test file. So we can do a git diff and we can type app test, and that will show us that file. And so we basically just required the test file itself in our intro test file, that's what all.spec is. It basically runs all of our tests. We then instantiate a new copy of the tests, and then we actually run the tests. And that's all that happens in this file. So if we look at the changes again, in summary, we added 3 new files, and then we basically added in hooks to the existing files for the help page, for the tests, and for the routes itself to hook into that route. And then the last thing is DB schema, and we'll actually go through that file right now. So if you go to app, there's this dbschema.json file, and this is, I think we've gone through it a little bit before, but this is basically for documentation purposes. All that really matters is that you have your collections defined. And you can see down here there's a new product collection that has been added for us that's just blank. We can go ahead and fill this in. Pretty much every object in Mongo is going to have an ID, so you can just copy that one. And basically you can just, let's say our product has a title, and that's going to be a string, and it's going to be, product 1 as an example, and it can have as many other properties as you want. You can use the user object for an example. Basically you just want to document the variable type, whether it's a string or a number or an object, and you can make objects like this. You can also use arrays like this, and you just want to document what your schema looks like, so if someone wants to figure out what information is going to be returned, they can actually look in here. So that's the DB schema file, and that file is included with database.js. So you can see right here it requires the schema, and then it's basically going to loop through each collection and give you an access to it in nodes. You can do like db.product.update or db.user.update, because those are our 2 collections. So that's kind of behind the scenes of what happened with creating this new API route, and now we will actually go through and write our new code and our test. Now that we have created our new files and looked at them, we're actually going to add a new method for our product backend controller and some tests for it. So if we go to our app folder, modules, controllers, and then product, we can open up our product.js file where we'll put our methods, and we can see the Yo generator already made a search, read, save bulk, and save actual and delete functions for us. And there are both public functions and private functions, so we can see that 3.5 is a private function, and that's because both save and save bulk will call the same function. That's just keeping things dry. And so what we're going to do is we're going to add a new method that's just going to be save title. Now we could just use save for this, but generally it's not a good practice to overwrite the whole object, because you can have concurrency issues if multiple operations are happening at the same time and you update old data. So this is kind of a convenience method to save everything, but you really only want to update the things that you need to. So for the sake of this example, we're going to make another function that'll just be called save title, and that will just save the title to our product. So we can scroll down to the bottom and we can copy our last function here, so we just keep the syntax. So we'll copy that and we will paste it underneath, and then we'll update our documentation and everything accordingly. So this will just save a product title, and this will be called save title as the function name. We're still going to pass in a product ID. This kind of uses YUIDoc syntax conventions, and so these brackets mean that it's optional. Product ID is going to be required in this case because we're going to assume we're only updating an existing product. So ID of the product to update, title for, and then our next parameter is going to be also a string, and that will be the title that we're going to use. So we'll just say title, and since we know it's a product, we can just change this to ID. We don't need the product in front of it. Title to save, and then we don't need this, and we are going to return the product itself. That's fine. And so we'll say save title is the name of our function. It's almost always going to take these three parameters. This is basically what the API route is going to pass into us. So a hook to the database so we can make database updates. The data itself is kind of like the front end data, and then if we have any custom parameters, if you're calling it from like a different place, you can pass them in here. They're almost always going to be promises, so we're going to always have this q.defer to have a promise, and then we're going to return a promise at the end. And just by convention, we just kind of have a message here that says what function we got into, just kind of for stack tracing. So we can delete all of this except the deferred resolve, and we'll just make that return ret, which is our return object. And now what we're going to do is we're going to say db.product.update, and we're going to update by object ID, which is this ID we passed in. There's a helper function for us that is MongoDB mod, which is just a service that comes with the seed. I think it's already included. It's not, so we're going to go ahead and include it here. So this is MongoDB mod, and we'll actually look at where that is. So it's in services, MongoDB, MongoDB.js. And all this does is just a helper module that will convert it to an object ID. It'll need to be the right format. A lot of times it'll automatically get converted to a string and you'll pass it around as strings, but when you actually make an update on the database, it has to be the right format, which is an object ID, a Mongo object ID. And so there's just a convenience function here that's make IDs, and you can pass in an ID or multiple IDs, and it'll return back to you the object ID form of it. And if it already is an object ID, it'll leave it alone, so it's safe to call even if it is an object ID. And so we pass in the data.id, and just so things aren't confusing, we'll actually set that here. So we'll say var ID object, so the object version, and we'll set that equal to this function right here, and then this will just be IDOb. So we're basically just ensuring that our ID is an object, the right format, and then we're going to make an update on that. We're going to make a set, and we are going to set the title property equal to data.title, which is what we passed in. And then that's going to return a function, which is going to give us an error and a valid key. And this is all Mongo database syntax, and you can look up Mongo JavaScript syntax and you can see what it is. You can look at this CRUD mod, which is another service, has a bunch of examples in it as well. So if you go to CRUD and then crud.js, you can search for an update. And so here we have same thing. We made IDs, we set our data. There's a safe parameter that's optional, and then error and result or valid. And so you can just look here for examples of what the syntax is, but it's similar to updating on the Mongo console. So we update the ID of the product that has this ID, we set the title, and then we return. So we'll say deferred dot resolve will happen after it's here. And we generally want to check to see if there's an error. So we say if error or not valid, then we want to reject because it didn't work. And if it did work, then we can resolve. So the way a promise works is you can resolve or reject. And we'll still return ret. So this is our new function that's just going to save a product title specifically. And so we can go ahead and save that. And just by writing this function, we have to call it. And so we need to give access to it in the API. And so that's what the API file is for. So if we go back to our controllers product folder, we have this product.api file. Same kind of thing. We have a list of all of our publicly accessible methods. You'll notice that the save private, which if you look back in product and we go to the top, we can see that this is a private function, this save actual, that's not accessible on the API. So you can't directly call this from an API method. You have to only call it from inside the function itself. So again, you only want to make public the methods that you want to be accessible. So this one we do want to make accessible, so we're going to say RPC save title, and then you can basically go through and find the instances of RPC delete and just copy it. So if we scroll down, we see we declare them here. So we say save title, this.rpc save title. You can just kind of copy the syntax from above. And then if we scroll all the way down, same thing. We can copy the last one for the delete, and we can modify it to fit ours. So we update our table of contents to 5. This is going to be save title. Same thing here. Save title, and then we're going to save a product title, and remember we just called it ID. It was a required item, so we do required true, and then here we have the title, and that type is a string, and required true, and then this is ID of product to save title for, and this is the title to save. And then this is just an example return, which we're going to return a product, so that's fine, and we want to call our save title method in product.js. And now we have given access to this file, or to the product code itself to make the database call through the API. And the way that we can test that is we can write some automated tests. So we can go to our third file, which is product.test.js. And if we open that up, same thing. we can add a new method here that is called save title. And if we go to the bottom, again, copy our delete. And the order actually does matter here, so we're actually going to put it before delete because delete's going to actually delete a product. If you were going to delete multiple products, which we also want to test, we might delete the product we want to update and then it won't exist and it'll fail. So you generally want to have the delete function be last. So we're actually going to take this search function and we're going to copy that one. And we're going to make this our save title. So save title. And then our parameters are going to be the product ID, which we have these products that we define at the top, and so you can see test product sub0.title, so we can update the titles here. So if you look at the top, basically all the scaffolding is built for you, and it basically gives you an example product or an array of example products, and so we can just use one of those. So we can do test product sub 1 or test product sub 0. So we'll go ahead and use test product sub 0. So if we go back down to our function, we'll say the ID that we want to update is test product sub 0 dot ID, and the title that we want to set it to is save title new product title. And then we're going to call our method, which is save title. And then we make our call. And then on our expectations, we can delete all of this except calling delete, which will go to the next function in the sequence. So we can delete all of this. And we can say expect data dot title dot to be, and instead of hard coding it, we can say var new title up here. We can make it a variable, so that way we won't have to write it twice. Keep our code dry. We can set this to new title, and we'll say we expect it to be bad title, so again we'll make it fail first. So if we save that, the last thing we need to do is basically when the way the backend tests are set up is you call the next test in the sequence, and so you'll notice the function we copied calls delete, and so does this one. We need to change this one, instead of calling delete, to call our new function save title, and that'll make sure that once it runs this one, it'll run this one next. And we're actually going to go over running the tests and seeing our code coverage in the next video. Okay, in this video we are going to run our tests and check our code coverage. So the way we do that is there is a grunt task called node cov, and as always, if you want to see that test itself in the documentation, you can always open grunt file in the main folder, and we can scroll down and we see right here is grunt node cov, and it says that it runs the backend tests and runs coverage for it. So always can look there for reference. So if we look at our output of our test, we expected undefined to be bad title as of one error. So we did expect it to error because we made it say bad title, but we didn't expect this to be undefined. So we can console log what data is, and then we can see what it is here. And if we rerun it, we can see what that says. And if we scroll up, we see message product save title right here, and we don't have anything but code and message. So we forgot to actually return the product itself. So if we go back to our code in our product.js file and we scroll down to our function, we didn't actually return the product. So we have product here, and we'll set it by default to a blank object. And if we successfully update the product, we will say ret.product equals, and we will just return the fields we edited. So we have ID, data.id, and title, data.title. And so we're just basically passing back what we got. So if we then save that and we run it again, we should now at least have title being defined. So it's still undefined, so let's see what happened here. So now we have product, so we actually have to do, it's inside of product, so we have to do data.product.title. So if we go to the product test, we want it to be data.product.title to be bad title. Save that. Rerun. And now we expect save title new product to be bad title. So we actually got it to output what we wanted it. So now we'll make the test pass. So we'll say we want it to be new title. Save that. Run it. And we can get rid of the console log now, since that was just for testing purposes. And we passed all of our tests. So now we can actually look at our coverage report. So if we go to our files, we will see in app and then src, we have this coverage node file and this lcov report folder. So if we go to that in a browser, again, you can use this. So if we need to make sure that our node server is running if it's not already. So node run.js. And then if we open a browser to localhost 3000 and then src coverage node and then lcov report, which is the name of that folder, we have our code coverage. It doesn't start out as high as the front-end code coverage yet for the seed, but we can go down to our app modules controller product that we made, and we can click on that, and we have our API file and our product.js file, so we can click either of them. Let's say the product file, and we can scroll down to our save title, and we can see that we got pretty good coverage. We didn't get into this if, so we didn't actually have an error. And there are some things in code coverage that are a little hard to test, or you're kind of writing code just to write tests for code coverage. Your database really shouldn't error that way. This may be something you want to abstract away into a different function for updates, like the CRUD module, that you can then force it to fail and just test once that, if the update function fails, that it'll handle it gracefully. But we could force fail it if we wanted to test this. But we have pretty good test coverage, and again, in addition to just lines of code, we actually have an expectation here, and we tested calling our method, passing in a new title, and ensuring that our new product actually has that new title. Now, one thing to note is we actually are just passing back the title we passed in. What we could and probably should do is actually do a read on the product, either in here or for test purposes. In the test file, we could actually do a read of that product and make sure that the title actually matches, because we could actually fail to update this title but just return what we passed in and think that it worked even though it didn't. So that's just something to note. Again, there are kind of different levels of how thorough you can make your tests. Really what we're testing is that we are passing back the title we passed in and that we didn't error, but we're not necessarily ensuring that the product actually got updated in the database. But for now, good enough. So that's how to write tests and see our coverage for a Node backend controller. And in the next video, we will talk about API help files. In the last video, we went over some tests. In this video, we're going to go through and look at our API help files, our interactive help, so we can manually use our API route that we just made. So if we go to a browser, we can go to localhost 3000 API help, and we have this new product option here that we can click on, and this is API product help, which you may remember is the same URL that was automatically added to the help file when we ran the generator. and we have these API routes here, and we can click on Save Title, and we have ID and title, which are required, and this is all comes directly from our API file. So if we go to our API file, we have save a product title as the info, which it says right here, save a product title. We have ID and title as our parameters. They're required, so that's where they're read. And we have info here, which has the ID or product to save title for, and title to save, which is right here. So it actually takes this right here and it directly puts it in our help, and this is interactive, so we can actually put an ID here and a title and get it back. So this is a way you can kind of manually test and see how your APIs work. So first we need to create a product. So if we go to save, we have a product object, and we can just say title product 1. So if we go ahead and type in title product 1, make sure we use double quotes, which is important, and we run the test. We can see that we got a code 0, which means it's valid, and we have this new title, and we have this ID here of this product. And we can copy that ID, and we can go to the read function, and we can pass in that ID and run the test and make sure that we did indeed have a product here that has product 1 as the title. And now we can use that same ID with our new function, and we can pass in a new title that says product 1 new title, and we can run the test. And we returned our new title here, and if we go to read now and we run it again, we see that indeed we have a new title. So you can actually go through, this is all interactive, and you can test your different methods, adding and deleting and updating different products, and you can do this for all your API routes, so it's a pretty nifty tool to quickly see what different API routes you have access to. And that basically sums up how to create and use and write tests for a new backend API controller. And in the next section, we will go over Angular end-to-end tests with Protractor. In the last section, we went over building a new Node backend API route. In this video, we're going to start going over Angular end-to-end tests with Protractor, starting with going over page objects. So if we go to our website folder files in our SRC front-end section, there's a test folder, and inside of that is an E2E folder, which stands for end-to-end, and we will notice a couple different files and folders here. The .scenarios.js files are the actual different test files that will be run, and then we have this helper folder, this page object folder, and then this no run folder, which is where we can put things temporarily if we do not want them to run. So we're going to start by going over page objects. So just like any other code, we want to modularize our code and abstract away the common things into functions and services. And that's called a page object for an Angular end-to-end protractor test. So if we click on page objects, we're going to start by going over the signup tests for creating a new user. So we have this signup.js file. Now if we open up that file, we can see that we can require files, so it's very similar to Node in terms of how we include other files. So // means go back a directory and then go into the helper directory and load config.js, and we can go into that directory. So if we go back into helper config.js, we can see that this file just loads our configuration for us, and we can go through this more later. But the idea is we can include other files from elsewhere, and // means in the same directory. So if we look in our folders back in E2E page object, we have this e2e.js file, so that's being included by our signup.js file. And then we have some code that is going to create a random string and an ID with a phone number for our user. So here's our mock user information. And it's really important to namespace things. We'll talk about this a little more later. We're potentially going to be running tests at the same time, and we want to make sure they don't conflict. So we want to have a random string here that's unique. So if this same code is being run more than one time, it's not overriding each other. And then we have this function here that we're going to export. Again, very similar to a backend Node file where we have an object or a function that we declare, and then we have different properties and functions on that. where we're actually going to do the meat of writing our tests and making our expectations. And then we export that, and that makes it available to other files. So we're going to go through all of the actual test code later, but this is just a high-level overview of how to include different files and combine them together so that we have modularized code that we can reuse, so everything's cleaner and easier to maintain. Finally, we'll just look at where this file is included. So if we go into the main folder, we have this signup scenarios file, and we can see right here we are requiring that page object we just went over right here. We're also requiring config and some other helpers here, and we're also requiring a different page object to help us delete a user. And these all get combined into this describe section where we actually write our tests and our it statements, which then call those functions. And you can see this is the actual file that runs all the tests, but it really just makes two calls to those page objects. So again, if we want to sign up a user from a different test, all we have to do is write one line of code. So really basic, dry, do not repeat yourself kind of code. We want to abstract away things into page objects, and by doing that, makes it a lot easier to write our tests. So in the next video, we are going to take the page object idea we went over here, and we are going to actually dive into that and look at some test code in the page object. In the last video, we went over page objects for modularization in end-to-end protractor tests, and in this video, we're going to go over filling out forms for our test. So if we go to the sign up page, which is the page that we are writing our tests for, we first log out and then go to sign up, and we can see we have this form here with a name, email, and then 2 password fields, and then the sign up button. We're going to actually simulate filling in these fields and then clicking the sign up button. That's what an end-to-end test does. So if we go back to our files, we have our page object file that we were looking at, signup.js, and again the top just makes a random user string that's unique, and then we have this nav function that we wrote in this page object, and what we do here, we can see we have these form inputs that we're filling in right here. So browser.findElement is how we access elements on the page with Protractor, and then by CSS allows us to pass in a CSS selector string to then access the correct element. So we can see right here we have abstracted out the .signup form here because that's common to all of our input fields, and then we have these classes here and this nth child, which is a CSS selector to go through the different children for the different fields. And the way we figured out what to type here, an easy way to do it is we can actually type it in the browser and we can inspect the element. So if we go back to our browser, let's say we want to get this first input field. If we inspect the element, we can see that it is an input field, and if you go up the DOM tree, we have this div class equals JRG form input. And if we look at our selector here, we have JRG form input cont right here. So if we go up again, we have JRG input form input cont right here, and we can see that this is kind of the different children of our form. And so this would be nth child 1, this would be nth child 2, nth child 3, which again we can see right here. So we have sign up form, nth child 1, 2, 3, and then we're getting the input field inside of those. So that's how we actually figure out what the by CSS section to be to get our correct element. And we can actually test this out in a browser. If we copy this, we can type on the console $ for jQuery, and then we paste that, and then we'll paste the rest of it. And then if we press enter, it will actually tell us what it returned, and indeed it returns an input field right here that has the name element. So when you're going through and you're deciding how to type it, you can always just test it on the console first to make sure that it actually is getting the element that you want. So now that we know we have the right element, we can fill in these forms, And the send keys is how we actually send input into an input element. And in this case, we're sending user signup.name. We're putting their email into the second one, which is our email field. In the third one, we're sending the password. And in the fourth one, we're also sending the password for the confirm. So these 4 lines right here, again, browser.findElement, and then use the CSS, gets the appropriate input element, and then actually fills in that input with the proper name. And then finally, we have same thing to find a button. We get the button here at the bottom that we want to click, and then we click it with .click. So these 5 or 6 lines right here basically fill out our entire form and then click the sign up button for us. So that's how we access elements on the page with Protractor, fill in input fields and forms, and then click buttons and other elements. In the next video, we'll go over putting all of this together so we can actually use this page object and actually put it together for our first test. In the last video, we went over how to select elements with Protractor and fill in a form. In this video, we are going to put that together to use that page object to actually write a scenario test. So if we go back to our files, we have in the page objects, we have this signup.js that just fills out the form for us. We just went over that. And if we go back into our root folder, we have this signup.scenarios file that actually puts the test together for us and runs it. So it uses Jasmine. So as with our other test that we've written, we have this describe block at the top that says we're going to test the signup functionality. We have before eaches if we need those. In this case, we don't. And up here, we require our page objects that we just went over that actually fills out our form and does the signup for us. And right here, we have an it statement, and it says make sure that we have a working signup route, and we can create a new user. And then it simply calls signup.nav. Now, signup again refers to the page objects that we exported, and if we look back at that, we can see that we are exporting the signup object, and the signup object or function has a this.nav property, so we can call signup.nav, and that will call this function. And we documented the parameters that we passed in. We have an optional user, otherwise it's going to use the default user, and then it's going to use that to call the function and then fill out our form that we just went over. So if we go back to our scenario file, we simply call that, and that's all we need to do to then create a new user. The final thing we need to do in this file is clean up. This is really important, also known as teardown, to make sure that we don't have any, this user we created is now going to be in the database, and every time we run the test, we would create a new one. So it's always a good idea, whatever you add when you're running the test, you completely remove. So you can look through this page object if you'd like, but basically this will just delete that user. So it just goes to the user delete route, which will then take the currently logged in user and remove them. And that's really it. It's pretty simple. Again, that's the beauty of abstracting things to page objects. We just have 2 it statements right here, one to sign up the user and then one to clean up and remove that user after they've signed up. And in the next video, we will actually run this test and see it in action. In the last video, we went over actually putting together our final scenarios.js end-to-end test, and in this video, we're going to actually run that test. The first thing to do is make sure that we have our Selenium driver installed. It should already be from the first step, but just in case, you can go to the README, and you'll notice this line right here for the Protractor WebDriver. You can copy and paste that into your terminal and run it, and it will update or install it if it's not there already. And once we have that, we are going to, for the sake of this video, remove the other tests that are already in here just because we want to only focus on the one that we just showed. So we're going to move them to no run, and now it'll just run this test. So now we can go to our terminal and type grunt e, and that will actually run our tests. So the first thing it will do is it will start our Selenium server. And once our Selenium server is started, it will open up a browser for us, and it will actually run our tests. So we can see we landed on the sign up page, we fill out the form, we click the sign up button, then we delete the user, and there we go. We ran our tests and we passed them, and there were no errors. So that means that we now have an end-to-end test that ensures that our sign-up functionality works the way it should. We actually opened a real Chrome browser and simulated a user signing up and clicking the button, and everything worked as it should. So that's the power of an end-to-end test. At a high level, make sure that your site works like it's supposed to. And in the next video, we'll go over some of the other concepts behind end-to-end testing we haven't yet, such as asynchronous control flow and promises. In the last video, we ran our end-to-end test with Grunt E2E, and in this video, we are going to go over asynchronous control flow with Protractor. So if we go to our files, you'll notice in the end-to-end helper folder, there's the config.js file, which we looked at a little bit before. And we can see here in the get config JSON file, we have this protractor.promise.defer. So we've already talked about promises a little bit before, and this is basically one of the preferred ways to handle asynchronous control flow, which basically means things return, but not in a synchronous manner, and we don't necessarily know when. It's not going to happen immediately. So in this case, if we want to get our configuration file, we have to actually get that file, which performs a request to load the right file. And even though it happens really fast, it won't return right away. So in this case, we create a deferred just like before, but we use a little different syntax with protractor in front here, and then promise.defer. And then at the end, we return deferred.promise, as we usually would. And then when we want to resolve that promise, we do deferred.fulfill. So usually it's deferred.resolve. Again, the syntax is just a little bit different here for this implementation. It's going to be .fulfill instead of resolve, but it functions the same way. Deferred.reject is the same as normal, so deferred.reject. So just like promises, we've already gone over these before. We basically have a function that doesn't return right away. So we set up a promise, we return that promise, and then when that promise is done, we either reject it or fulfill it. The other thing we'll talk about, another piece of asynchronous control flow in Protractor specifically, is browser.execute async script. Basically, there's a lot of things that Protractor handles for us in terms of handling timings. It's built to work with Angular, so it will kind of wait for one function to finish before it'll run another one, and it handles the scope and all that kind of stuff. But if we want to do something that doesn't happen in a synchronous manner, we have this browser.execute async script command. And you can read about Selenium and Protractor to see the different API calls you can make. This one will basically give us an asynchronous control flow that we can use to then have a callback that we pass in. So that's another way that we talked about async before with using callbacks, where you can return this asynchronous script and then give it a callback, and then when it's done returning, it will work. So this function get config JSON, we call right here, and it will return to us a promise, and that will execute right here. So there will just be some times that you need to use it. It can be a little bit confusing at first, but you can kind of use this example to build off of. It will usually be used with Angular Injector right here as a way to actually return something when we need to, and that will give us access to it in an asynchronous manner as we need it. So those are the two main ways that you'll deal with asynchronous control flow in Protractor. Most often it will be promises, which is already what you know, but just a little different syntax with this protractor in front and fulfill instead of resolve. And then this browser execute async script, which you'll need to use every once in a while. In the next video, we will talk about Angular and accessing Angular modules inside of Protractor. In the last video, we went over asynchronous control flow in Protractor, and in this video we are going to go over injecting and using Angular modules. So if we go back to that same config file that we were looking at before, which again is in E2E helper config.js, you'll notice this angular.injector line right here, and we are getting app config, which is a service that we have in our app. And what this line does is it allows us to get access to Angular modules if we want to use them. In this case, we want to get access to our JSON configuration. And to do that, we have it stored in our app config service, and so we need to access that app config service. And unlike when you're in an Angular file, like a controller file, where you can just dependency inject that service in at the top and then you have access to it, and here in Protractor we have to use this angular.injector line. My app is going to be the name of your application. For the mean seed, we just call it my app, but if you were to change that main module, you would change that. This is the same thing that was in our Angular unit tests as well when we were injecting the whole module. And then this .get line actually gets the specific module that we want. So we set it equal to a variable, and that is how, if we want to use Angular modules, we can access them. Another example of this is in the API call file, which is a more complicated file but has the same pattern. Again, you'll wrap the Angular injector with this browser.async script line. And in this case, we're getting the app HTTP module to make backend requests. And once we have that, we can then call the app HTTP go call just like we could on the front end and use it like normal, but we return this callback because we're in this async script line. So again, back to config.js, a simpler one. If we just want to get any sort of a module, which is pretty much always going to be a service, in Angular we use this angular.injector line. In the next video, we will go over setup and teardown more specifically, and using mock data for our tests. In the last video, we talked about Angular injector to access Angular modules in Protractor, and in this video, we are going to go over setup and teardown using mock data to prepare and then clean up after our tests. So if you remember, we had the helper API call.js file we looked at a little bit. This makes backend requests using our HTTP module that we use in Angular. And if we scroll down, we can see that there's this user sign up and log out function, and it creates a bunch of users here, and then it makes this call to EDE mocks user sign up and log out. This EDE mocks is a backend controller we make specifically for the end-to-end tests here that will create users for us and do a bunch of backend calls. So when we are running our tests, if we need to log in a user has to already exist. And because we want to use a clean database each time we run the test and then wipe it afterward, we need to actually seed the database with some real users and then log them out, so then we can simulate logging them in like normal. So if we look at this backend file, it's just a node controller like any other node controller. So if we go to the backend app, modules, controllers, and then EDE mocks, we have the same three backend files, our API file, our main file, and our test file. And if we look at our EDE mocks file, this user sign up and log out function, we can see that we take the amount of users that were passed in and we do a loop through them, and then we call our authorization module to create those users, and then we log out those users. So we can make as many end-to-end backend calls as we need here. They're basically going to do all the setup in one API call for us, and then all the teardown in one API call for us for whatever type of test we need. And in this case, we needed to sign up a certain amount of users and then log out all of those users. So if we go back to our API call front end call, we can see that if we call this function right here, it's going to create a certain amount of users. We can pass in an integer of the number of users that we want, and it will log them all out, and then it will return those users to us so we can then access those users. And an example that we can look at to see where this is used is in the login file. So if we go back to our front end end-to-end tests and we go to E2E and we go to our login scenario, we see that we include the API call helper, and then first thing we do is setup. We sign up and log out the users. In this case, we only need one user, so we do API call dot user sign up and log out, and then pass in 1, and then we set the returning user equal to that user, so then we can access that user and then log in that user later. So that's how we would do setup, and at the bottom we do teardown. We use user delete, which is the same kind of thing, but it actually will delete the user that we created in the first place. So it's very important to do setup and teardown in all of your tests so you have a clean database both before and after, and you don't leave anything behind. So that's how you can do setup and teardown with mock data. And in the next video, we will talk about interacting with third-party sites with Protractor on our website. In the last video, we talked about setup and teardown with mock data for our end-to-end Protractor tests. And in this video, we're going to talk about interacting with a third-party website where we get out of Angular World and we still need to access things and simulate user input. So if we go back to our scenarios, we can see that we simulate Facebook login and Google login. And when we do those, we're actually going to go outside of the Angular world into like a pop-up to type into a form that is created by Facebook or Google. So we'll start by looking at Facebook. So if we go to the page objects section, we have this login Facebook helper. And if we look at this, we can see that it starts out similar. We do a browser.get to the login page. We expect that the browser URL is appropriate. We click the Facebook login button. But then we have this browser.get all window handles. And what this does, as the comment describes, is when we click this login button, it's going to make a pop-up for Facebook that we're going to then need to click in that new pop-up instead of the page that we're currently in, and then input information into that form. So if we do this browser.get window handles, that'll give us access to the windows, and it will return a promise with an object that has all of our handles. And there is some like timing issues that can happen if you try and access it immediately, so we just do a browser.sleep, and that will just make sure that the Facebook page loads so we actually have the login form to type in. Otherwise, when we try to access the element, it won't exist yet. And again, when we're inside of Angular world, we don't have to do this because Protractor handles that for us. It doesn't try and run the next command until things have loaded. But because we're outside of Angular world in this new window that's just a Facebook window, we need to manually wait, essentially. And so now we have this browser.driver. So once we're outside of Angular world in this new window handle, instead of just using browser dot, we're going to use browser.driver. And then everything is pretty much the same after that. So we get an element, this time by ID, of the Facebook pop-up, and we send the keys, and we do the same thing for the password, and then we click the login button. And again, if we want to actually see this in a browser, so if we click the Facebook button here, we can see that it takes us to this new page, and I'm already logged in, but it would have a pop-up here that would show for us, and it would have a form. So if we go back here, we then again sleep a little bit to let the Facebook login happen, and then we go back. So if we want to interact with the third-party site, we can look at the Google login. It's very similar. So same kind of thing, we get all the handles, we sleep. This one we can sleep a little bit less, and then we look at the IDs, which once the pop-up happens, then you're just going to look at that pop-up and fill in the forms appropriately, and then you go back. In this case for Google, we have to approve. So we have another sleep, and there's another pop-up that Google will show us that we need to approve. And then we go back into the Angular world and return. So that's how we interact with third-party sites and if we have pop-up windows. And in the next section, we will go over deploying our website live so it's publicly accessible. In the last section, we went over Angular end-to-end tests with Protractor. In this section, we're going to talk about deploying live, starting with this video, which is going to talk about buying our server. So if we want to deploy things that we have on our local machine right now, like we've been coding, and we want to share them with the world so other people can access them, we need to get a server that's hosted in the cloud that has a public IP address or domain name so we can then access it. So the first thing to decide is which server to buy, and the first kind of decision is, do you want infrastructure as a service, which is IaaS, which basically means you just get a box, and it's just kind of like you had a Linux computer, but it's hosted for you. And then there's PaaS, which is Platform as a Service. And if you just Google that, there's lots of articles that will describe them. Here's one right here I'll click on from Rackspace, and it kind of describes with this little pyramid right here. Software as a service. At the top is, you're not really going to buy a server like that, but that's kind of like people will make those and then give them to like other people, companies, when they kind of bundle everything up for you. Then Platform as a Service, a popular example of this is Heroku. And that means they'll handle the infrastructure for you, and then you'll just deploy things on top of that. The pro to a Platform as a Service is that because they manage things for you, they're going to have people who are server experts and admins who are going to be able to do all that stuff for you, but you're not going to have as much root access or be able to access things as easy. There are going to be some things that are a little bit more complicated, potentially, if you want to do stuff down at the server level, because you just won't have as much access. Infrastructure as a Service is the bottom level. It's also the cheapest because you're just getting pretty much a raw Linux box. And it means you have root access, so you can do whatever you want, and you won't be hindered by anything, but you also don't get really much support necessarily, and if you break something in your server, it's up to you to fix it. So pros and cons, the different levels. For this case, I would recommend going with DigitalOcean, which is an infrastructure as a service, because that's what I've tested the seed on. It also does work with Heroku, but you have to use Circle CI and some other continuous integration things. I would just start with DigitalOcean, which is one of the more popular IaaS solutions, and it's also really cheap. It's only $5 a month, which is a really good deal. So if you go to DigitalOcean, go to pricing, again, we can see it starts at $5 a month. So you can start here, and if you don't like it, you can quit next month. You could switch to a different server. But I know this will work with the mean seed, and the setup instructions will work with DigitalOcean. So you basically just sign up and you create your first server, and it will give you an IP address and root access. They'll email to you, so you can then SSH into your server. So they have instructions to do all that. Just click the sign up button and go through the process, and then once you have that all set up and you have root access, we will, in the next video, walk through setting up your server. In the last video, we talked about how to decide which server to choose, and we recommended using DigitalOcean, which is a Linux server, which is what we'll need. And once we have our Linux server, you should have your root access and admin that we'll be able to use to SSH into our server and set up our server, which is what we'll do in this video. There is documentation for all of this, so if we go into the main root folder and we look at the docs folder, there's setup running folder, which has a bunch of setup files, and we have this server linux.md file that we can open. And if we close the rest of these windows here, we can see that it'll take us through. So it says SSH in, and it tells us the syntax. So user at IP address or domain, and it has an example. And then we will add users, which I've already done. And so I'm just going to go straight to this step, this SSH in, but I already have a user, so I won't have to do root, but you'll use root first time. So if we go here, we do SSH, my user is Elmadera, and then your IP address is going to be what you have in your server. So when I'm logged into my DigitalOcean, this is a server that I created. I can copy that and then paste that in here. It may ask you to authenticate. If this is the first time you've done it, just type yes, and then you can type your password, and then it will say welcome, and now you're into your Ubuntu Linux. When you choose your distribution, I would choose Ubuntu. As long as it's Linux, you're fine, but most of the steps are for Ubuntu specifically, which is one of the more popular Linux distributions. So once we're in, it's just like any other server. We can type ls to see our files. We can go to the root and then type ls and see our files. And again, we're just going to go through this README. The steps should be pretty straightforward. There are a decent amount of them, but you should just be able to walk through them. So we add our user, we log out of root and re-log in. We update our Linux box. We install Git, we install Node, we install MongoDB, we install PhantomJS. So very similar to exactly what we did locally, but just Linux specific commands if you didn't have Linux before. And that's basically it for this video. That will install all of our basic things. In the next video, we will go through and we will actually set up our site with continuous integration to run on our public URL. In the last video, we SSH'd into our server and did the initial server setup tasks following the instructions in the documentation. And in this video, we are going to finish setting up our actual website and deploy it with continuous integration. So to do that, we just follow the next README. So if we go back to our files, we have in here this setup file, we have a deploy.md file. If we open that one up, at the top it tells us to follow the server Linux setup if we haven't already, which is what we did in the last step. And now we just have a bunch of instructions. Again, they should be pretty straightforward, and we're just going to go ahead and follow them. So we install some global NPM packages just like we did locally, and then we are going to, on our local computer, we're going to create some configs that will have different sets of variables to work on Linux and to work for our live server. So if you wanted to do this, we already went over the configs in an earlier video, but we have this app configs folder. You can copy one of those, and then we want to rename it to our server version. And same thing with the test one. So once we update that, and it tells you in this documentation which ones to change. So we want to change operating system right here to Linux, and we want to set forever to 1 and update the domains if we have a domain name. So it just tells us what to update, and once we have that, then we want to copy that and do our test file. So copy this, and we'll have another one that is our test version. And it tells us to make our test updates. And then we have an option to do it with continuous integration or not. I highly recommend continuous integration. It has an example of variables here. You're going to replace them with your own email and your own GitHub account that you created in the beginning to access this. And then if we haven't already created a GitHub repo, we should have already done, then we can set that up. We type these commands into the server, and again the instructions tell you where these commands should be typed, whether it's on your server or on your local computer. And we're going to install Concrete, which is a CI server, which stands for continuous integration. And this is really cool. What this will do is every time you just type git push, we'll use git webhooks to automatically deploy our application, which will mean like basically just running grunt on our server, so that every time we push to GitHub, we can then update our live server. So we can code locally and then just in one easy command update our server, which is really cool. So we follow these steps to download the Concrete server. We update some permissions, install things with npm, and then we do some more setups. So we clone the GitHub repo that we have onto our server. We just need to do that the first time. We set some permissions. We then update our config environment JSON variable, which we went over in an earlier video about configs, because on our server we wanted to use this new config server that we created instead of our regular config. So we set up that, and we set up a branch. So generally we don't want it to run on master. We may want it to run on staging or production, whatever branch we push to. You want to have a different branch generally for each different environment. And so when you push to that environment, it'll automatically run. And then we finally set up these Git hooks that will, as the name implies, hook in every time a Git push is received. It will trigger this process to start going. So we will run grunt and do everything we need to do. And we then finally run Concrete to get it going. And once Concrete, which is our CI server, continuous integration server, is going, we can then make a push, and then it should automatically update our site. And if we want to see what this looks like when it's all done, again, these steps should be pretty straightforward. If we type in that IP address right here for our site. The default continuous integration port is 3010. So if we type that in here, we can see Concrete is running, and it has a list of every time we've pushed. In this case, there was a bunch of failures which we needed to fix, but then we have a bunch of successes. And so every time it'll have a history here of every time you've pushed, and if it was successful or not. You can click on it and you can see it, all the commands it ran. So basically it runs npm install and bower install, and then it runs the production version of Grunt, and that's really all it does. And that will basically make things all ready for our server to run, so then we can actually view our site in a live browser. So that is how you get your site from on your computer to on a public URL, and we did it with a continuous integration server, which makes it really easy because then you just type one get push command and it does all the rest for you on the server. So that's how to deploy live, and in the next section we'll do a recap of everything that we went over in the Meanseed stack videos and tie it all together. In the last section, we went over deploying our site to a live public URL. In this section, we're going to recap everything we've done in the course so far, starting with installing our Meanseed generator. The way we did that is if we go to GitHub and we go to generator Meanseed, we have the Getting Started section, which helps us install our different programs for our operating system, and then some global npm installs. We install the generator itself, and then we set up our yo configs folder and ran yo Meanseed. Once we ran yo Meanseed from the terminal, just like this, we were given a list of options, and we picked the core default as the one that we were going to use right here. And after we did that, it actually scaffolded out our app for us. After we did that, we then ran local installs, npm install and bower install, every time we needed to, and ran Grunt to build our different assets so we could run our site. Once we had run Grunt, then we could view our site, and we would do that by first running our Mongo instance, which we can run with mongod, and then running our node server with node run.js. And once that's running, it tells us that it's looking at localhost 3000. So if we go to a browser and we go to localhost 3000, we can actually see our site. So that's an overview of how we set up our Meanseed and got our initial site running in a browser. And in the next video, we will talk about the overview of how we use our web debugger and did some of the next steps. In the last video, we went over setting up our Meanseed generator and running our website and viewing it in a browser. And in this video, we're going to go over the Mean technologies again. Mean, remember, stands for Mongo, Express, Angular, and Node. And our main front-end technologies are CSS or less, which is a CSS preprocessor, HTML, and JavaScript. And if we look at any of our front-end files, which are in the app SRC section, and go to like modules, we have pages, and we looked at this test file a lot. We have our HTML file, our less file, and our JavaScript file, as well as a test file. So these are the three main technologies that we're going to use on the front end to build our site. And when we view our site, we have a debugger, which we can right-click on the page and go to Inspect Element. And that way we can see our different elements or our HTML, and sources show us our JavaScript files that are using to run our site. We also have the console here, which we can see different output like console logs and type things if we want. Finally, we have MongoDB, which is our backend database layer. And if we open a new console, we can actually just type Mongo, and we can use our Mongo from the shell, and we can see what's going on. We can type show DBs to see our databases. We can use Mean Company, which is the site that we're currently using, and we can do like db.user.count to see a total number of users, which right now is 2. So that's a recap of our main technologies in the mean stack, and in the next video we're going to do a recap of Angular. In the last video we went over a recap of our mean technologies, Mongo, Express, Angular node, and in this video we're going to do a recap of Angular. Angular is our front-end JavaScript MVC framework, which stands for Model View Controller, and we have some routing in Angular. So in our front-end SRC folder, we have the common folder that has our app.js file that handles the routing for our app. Angular is a single-page app, so we also have in the main SRC folder our index.html file. This is where we have our only HTML tag in the whole app, and everything else we include all of our assets, and then all of our individual pages load into the ngView element. And the bulk of the work that happens is in the modules folder, and Angular is basically broken into 3 different types of modules. Directives, which are our most powerful set of modules, and these are things that touch the DOM or the HTML, so they touch the view layer. We built a directive called myDirective that did some simple functionality. And after directives we have services, which are similar to directives in that they're reusable components, but these ones do not touch the view layer or the DOM. And we built a simple items list service that creates a set of items for us. And then finally we have pages or controllers, which then load the directives and the services. So we worked with the test page, and we have in our HTML file, we access some directives that we created, as well as we can use ngClick and other directives that are built in with Angular. And if we want to access services, we do that from the controller file by dependency injecting those services in up here, and then we can access them. So that's an overview of Angular and our directives, pages or controllers, and services. And in the next video we will do a recap of Node, which is our backend. In our last video, we did a recap of Angular, which is the main tool for our front end. In this video, we're going to do a recap of Node.js, which is our main tool for our backend. If we look in our main website folder, we have the app folder, which has all of our backend files. And in our backend, remember, we load everything from run.js, which is in the main folder, and that's why we type node space run.js to start running this file. And run.js then accesses index.js, which then accesses server.js, and then accesses our database.js file, as well as going into our routes folder, which configures all of our different routes. And we use the RPC method, and we don't need to understand all of the inner workings of these files, but it basically sets up all of our backend routing for us. And our backend routing happens for us in Node API routes, and our controllers are collections of 3 files. We have our API file, which if we open up actually creates our help page and is our documentation. So for each of these methods here, we have our information about that API call, and then we have our parameters that we pass in, as well as some documentation for them. And then we actually call a function in our main file. And remember, we can go to a browser and we can see the help by going to localhost 3000 API help. And this will show us an interactive help tool that we can use, where we can actually type in things and search for users and run interactive tests, and we can see the users that came back. We just have 2 of them in this case, and we can go through the rest of the methods over here as well. So this is our interactive help for our backend API calls. And going back into the code, our next file is our main file that the API file calls, and this is where our actual methods are that will interact with the database and do the actual work and the logic. And finally we have our test file, which is where our automated tests are. And the last thing about the backend is that it interacts with the database. Again, that happens in the main file for each of our different API routes. And if we go to any of these functions, for example, if we scroll down, we can see that pretty much all of them will interface with the database. And some of that logic will be abstracted out into the CRUD service, which we can look in here. And here we can see there is a bunch of calls that will be made to the database. So if we were passing in the user collection, we would do db.user.insert, and that would insert in a new user for us and create it in our database. And that would be MongoDB, which is again the mean in the mean stack. So that's an overview of Node, which handles our backend, which pretty much just interfaces with the database with a bunch of API route calls. And in the next video, we will go over automated testing. In the last video, we did a recap of Node.js, which is our backend, and in this video, we're going to do a recap of automated testing. There are basically 3 different levels of automated testing that we do. The first is unit testing, which we do on the front end using Angular Karma. So if we go to our front end SRC folder, and we go to a module, such as a directive that we wrote, we have this spec file, and this spec file has a bunch of tests in it. And we just wrote a simple test in this case, but it's a combination of Jasmine describe and it blocks, and each it block makes an expectation, at least one expectation, to confirm that the functionality actually does what it's supposed to do. So in this case we have a directive, and we want to make sure that it properly takes and uses a scope 1 property. So that is a unit test with Angular Karma. The second type of test that we went over was a backend integration test on the API routes. So if we go in the backend app modules controllers, we can open any of these, and we have a .test.js file. And if we open that file up, we have a bunch of tests that are run to make sure that each of the API methods does what it's supposed to do. So we can set up some mock data here for some test users, and we have some cleanup and teardown. And then once we've properly removed all of the users so our database is clean, we can then actually create some users, and we have our describe call here, and then we make an API request to our auth.create method, and then we expect that we have a user that we got back that has the correct name that we passed in, for example. And so we have a bunch of these different functions that test all of the different API routes for us, and that makes sure that our backend API calls don't have any errors and that they return what they're supposed to return. Our third type of test is an end-to-end test that we use Angular Protractor for. If we go back into our front end in SRC, and then we go down to test, we have this E2E for end-to-end folder, and then we have these different scenarios. And we modularize our tests, so we have this page object and this helper folder that actually abstracts some of our code away. We went over the signup page object and test, which allows us to actually simulate filling in a form using some CSS selectors and send keys to add in our inputs, and then click the sign up button to actually simulate creating a user. And this page object called from the main directory signup.scenarios.js, which just has, again, Jasmine describe and it blocks, and the first it block just signs up our user using that page object abstracted function. And then we do some cleanup, which is really important. Whenever we mock data, we want to make sure the database is clean before and after our test, and that is an Angular Protractor end-to-end test. And that is a summary of the 3 types of automated testing that we have. And again, we have code coverage that we can run with a grunt task to make sure that we're getting good code coverage and making sure that our application is well tested and does what it's supposed to do. In the next video, we will do a recap of deploying and making our site go live. In the last video, we did a recap of automated testing, our unit integration and end-to-end tests. And in this video, we're going to do a recap of deploying our website to be live at a publicly accessible URL. The first thing we did was we bought a server that is publicly accessible, and we just used DigitalOcean. So if you just search for DigitalOcean, it'll come up. We created a new DigitalOcean account and created our new droplet, which is our new server. And once we had that, we got an email with our SSH login information. And then we went into a console and we logged in with our username. Again, we would start with root in the beginning and whatever our URL or our IP address is. And once we did that, we would type in our password and then we would be logged into our Linux machine in the cloud. And then we would set up our new Linux machine just the way we set up our original machine, but this time it would be a little different because it's for our live site. And the way we did that was simply following the readmes. So in the main directory, we have a docs folder, and in the docs we have setup running, and then we have server Linux. If we open up that file, it has detailed instructions of how we SSH in, add our user, log out of root, update our app, and install our main programs, Git, Node.js, MongoDB, and PhantomJS. Once we have installed those programs, we can then actually finish setting up our website on our Linux server by following the deploy instructions. So we install our global NPM packages, we update and create a new configuration for our new environment, and we edit some properties for it to work on Linux and to run our live server. We then set up continuous integration. We used Concrete and GitHub webhooks so that we could automatically deploy with a single command with a git push, and we followed the steps to do so. We created our GitHub repository if we hadn't already, set up our Git with some global configuration, we installed our Concrete continuous integration server, we did some setup and made it use the config environment that we set up locally. We set up our Git hooks to hook in so that every time we did a git push, it would automatically build our site on our new Linux server. And finally, we ran Concrete and then did a push. And once we've done that, now every time we push locally, our live server will get updated and we now have a live, publicly accessible, deployed website. So that's how we set up and deploy our server. And that is it for this course. We went from the beginning of having nothing to using the mean seed generator and learning those main technologies to be able to build and deploy a live website.